There's a place in the night sky where the rules of our universe seem to bend, a distant, swirling tapestry of stars and secrets called the Small Magellanic Cloud. Just one look through a telescope reveals a realm where the ordinary becomes extraordinary, where celestial objects behave in ways that leave even the brightest astronomers utterly baffled. Imagine a cosmic playground filled with 50 strange anomalies, objects that glow with eerie light, move in impossible patterns, or vanish without a trace. These aren't just quirks of nature, they're cosmic riddles waiting to be solved, and today we're diving deep into their mysteries. What makes this corner of space so special? The Small Magellanic Cloud is more than just a satellite galaxy orbiting our Milky Way. It's a laboratory of the bizarre. Here, stars burn in colors we've never seen, dust clouds form shapes that defy logic, and some objects emit energy so strange it challenges everything we know about physics. Think about that for a moment. In a universe full of wonders, these 50 objects stand out as the most perplexing of all. Some might be remnants of ancient supernova, others could be black holes dancing in ways we can't explain, and a few might even hint at forces beyond our current understanding. This isn't just a journey through space, it's a voyage into the unknown. Each of these 50 objects tells a story, a puzzle piece in the grand mystery of how our universe works. And the most thrilling part, scientists are still uncovering new details about them, rewriting the textbooks with every discovery. So, if you've ever stared up at the stars and wondered what secrets they hold, you're in the right place. Together, we'll explore these celestial oddities, uncover their hidden truths, and maybe, just maybe, catch a glimpse of the cosmic forces that shape our reality. Ready to begin? Let's go! Among these 50 cosmic enigmas, the Ghostly Nebula X-1 stands out as one of the most haunting mysteries. Picture a vast, luminous cloud drifting through the Small Magellanic Cloud, glowing with an ethereal blue light. But here's the catch: no one knows what's powering it. Most nebulae shine because of nearby stars or the remnants of stellar explosions. But Nebula X-1 floats in eerie isolation, with no visible source fueling its radiance. It's like finding a lamp glowing in a dark room, unplugged and untouched, yet still casting light. Adding to the puzzle is its shape, a twisting, almost serpentine structure that defies the usual billowing forms of typical nebulae. Some astronomers suggest its bizarre contours could be the result of hidden magnetic fields or unseen cosmic collisions, but so far, no theory fully explains its form. And then there's the strangest part: it hasn't faded. Nebulae usually dim or disperse over time, but X-1 has remained eerily constant for decades, as if locked in some eternal state. What could possibly sustain it? Hypotheses range from the remnants of a long-dead star we simply can't detect to exotic phenomena like dark matter interactions or even an entirely new kind of celestial object. Every time researchers point their telescopes at it, they come away with more questions than answers. The Ghostly Nebula X-1 isn't just a cosmic oddity, it's a silent challenge to our understanding of how energy and matter behave in the universe. And until we crack its secrets, it will keep shining mysteriously in the void, a spectral beacon defying explanation. The twisted star cluster Y7 looks like something out of a cosmic ballet. Except there's no choreographer, and the dancers are stars moving in ways that shouldn't be possible. Nestled in the Small Magellanic Cloud, this cluster contains hundreds of stars spiraling in perfect synchrony, their paths bending into elegant, interwoven arcs as if pulled by invisible strings. Normally, gravity alone dictates how stars move, creating predictable orbits or loose groupings. But Y7 stars defy those rules, twisting through space with eerie precision, like a celestial whirlpool frozen in motion. So what could be causing this unnatural dance? One leading theory points to dark matter, lots of it. If an unusually dense knot of dark matter lurks at the cluster's heart, its extra gravitational pull might be sculpting those spirals, yanking stars into alignment like marionettes. But here's the problem. We've never detected dark matter interacting like this anywhere else. Another idea suggests an external force, something massive yet unseen. Perhaps a rogue black hole or a debris stream from a long-vanished galaxy tugging at the cluster from afar. Or, most mind-bending of all, could Y7 be the aftermath of a collision between two star clusters, their combined chaos frozen into this hypnotic pattern? Every time astronomers try to simulate Y7's behavior, their models break down. The math says this shouldn't exist, yet there it is, glowing defiantly in our telescopes. Some researchers even whisper about more exotic explanations, like residual effects from a warped patch of space-time or an ancient, hyper-advanced civilization's abandoned experiments. While that's unlikely, it highlights just how baffling Y7 truly is. One thing's certain, this twisted star cluster isn't just a curiosity, it's a challenge. A single celestial anomaly forcing us to rethink how gravity, dark matter, and even time itself shape the cosmos. And until we solve its riddle, Y7 will keep spinning its silent mystery, a reminder that even in the vastness of space, some secrets refuse to unravel easily. Deep in the heart of the Small Magellanic Cloud, a cosmic metronome ticks with impossible precision, a pulsar designated Pulsar J0108, pulsing at a rhythm that shouldn't exist. Pulsars, the ultra-dense remnants of dead stars, typically emit beams of radiation like celestial lighthouses, their beats so regular you could set clocks by them. But Pulsar J0108 defies the rules, firing off bursts in a stuttering, irregular pattern that flickers between high-energy gamma rays and low-frequency radio waves, sometimes within milliseconds of each other. It's as if a drummer suddenly forgot the song mid-beat, then improvised a solo in a language we don't understand. What makes this so baffling? Neutron stars, the collapsed cores that birth pulsars, are supposed to rotate with near-perfect stability, their emissions tied to their spin like a spinning top's wobble. Yet Pulsar J0108's pulses arrive in chaotic clusters, with some signals arriving 10 times faster than predicted, while others vanish entirely for hours before reappearing without warning. Imagine a heartbeat that alternates between hummingbird flutters and the slow thumps of a hibernating bear. Even stranger, its magnetic field, normally a pulsar's defining feature, measures weaker than expected, as if something is suppressing it. Possible explanations range from the unsettling to the revolutionary. One camp suggests the pulsar might be trapped in a turbulent dance with an unseen companion, a black hole or dense debris field, rippling spacetime so violently it disrupts the star's spin. Others propose more exotic ideas, fractures in the neutron star's crust causing starquakes that reroute its energy, or even a rare quark star, a hypothetical object so dense its core dissolves into a soup of raw subatomic particles. But the most tantalizing theory, that we're witnessing the birth of an entirely new class of pulsar, one that operates on physics we haven't yet written into the textbooks. Every flicker of Pulsar J0108 is a cipher, a coded message from the far edge of known physics, and until we crack it, this cosmic outlier will keep pulsing its erratic rhythm, a reminder that even the most familiar objects in the universe can hide breathtaking secrets. The Dark Vortex stretches across the Small Magellanic Cloud like a tear in the fabric of space itself, a region so utterly lightless it swallows starlight without a trace. Unlike a black hole which betrays its presence through violent gravitational ripples or glowing accretion disks, this void gives nothing back. Telescopes peer into it and see only absence, as if someone carved a hole in the universe and left behind perfect, unfathomable darkness. How does something like this exist without a detectable black hole at its core? One theory points to exotic matter, a hypothetical substance with negative energy density that could bend spacetime in ways we've never observed. Imagine stretching a rubber sheet until it thins to nothing. Exotic matter might twist space so severely that light can't escape, creating a darkness that mimics a black hole without the crushing singularity. Another possibility, the vortex could be a cosmic illusion, a trick of perspective where overlapping dust clouds and gravitational lensing create the perfect alignment of shadows, except no known arrangement of matter explains its depth or stability. Then there's the strangest idea of all, spatial distortion. Some physicists suggest the vortex might be a knot in spacetime itself, a region where the normal rules of geometry unravel. Picture a whirlpool in water, but instead of liquid, it's the fabric of reality spiraling inward. If true, this could mean the vortex isn't just hiding light, it's warping the very dimensions around it, a phenomenon predicted in extreme physics but never witnessed until now. What chills astronomers most isn't just the vortex's darkness, but its silence. No X-rays, no radio waves, no telltale energy signatures, just an expanse where the laws of physics seem to pause. Could it be a gateway to something beyond our universe, a flaw in cosmic structure, or perhaps something even more unsettling, a natural phenomenon we haven't invented the math to describe yet? Every observation deepens the mystery, leaving us staring into the abyss and wondering if the abyss is staring back. Hanging in the depths of the Small Magellanic Cloud, there's an object so uncanny it seems ripped from the pages of a science fiction novel, the Mirror Galaxy Fragment. Picture a colossal, jagged shard of cosmic glass, its surface flawlessly reflective, capturing and duplicating the light of every star and nebula around it with eerie precision. Unlike ordinary celestial bodies that absorb or scatter light, this fragment behaves like a celestial echo chamber, bouncing back images of nearby star systems so vividly, early astronomers initially mistook them for real clusters. What makes this phenomenon so unsettling? Natural mirrors in space like ice-covered moons or metallic asteroids exist, but they're tiny and imperfect. The mirror fragment, though, spans nearly half a light-year, its surface so smooth and flawlessly aligned it defies all known geological processes. Even stranger, its reflections aren't static. They shift and warp in real time, as if the fragment is somehow processing the light it receives, not just reflecting it. When a supernova flared in a neighboring system last year, the fragment didn't just mirror the explosion. It amplified it, projecting a distorted, high-contrast version back into space days before the light from the actual event reached telescopes. Could this be some freak natural occurrence? One hypothesis suggests an exotic form of crystalline matter, forged in the heart of a long-dead star, might have cooled into this impossible structure. Another theory blames dark matter interactions, proposing that invisible particles could be aligning the fragment's atomic structure like a cosmic loom weaving a perfect reflective tapestry. But there's a more provocative idea: artificial origin. The fragment's edges show geometric patterns too regular for random cosmic erosion, and its reflective properties align suspiciously well with theoretical models for quantum-based communication, arrays technology far beyond our grasp. Here's the chilling part. Last month, the fragment did something unprecedented. It stopped reflecting. For exactly 47 minutes, it went dark, as if switched off, then reactivated with a slight but measurable change in orientation, now tilted precisely toward the Milky Way's core. Coincidence or something more deliberate? Whether this is nature's most bewildering quirk or something far more profound, the Mirror Galaxy Fragment refuses to surrender its secrets. For now, it hangs silently in the void, a polished enigma waiting for us to decipher its purpose or to reveal it on its own terms. Drifting through the emptiness between stars, a solitary wanderer defies the cosmic norm, a rogue planet untethered from any sun, yet crowned with a spectacle no one saw coming, luminous rings that flicker like a malfunctioning neon sign. This isn't just another frozen world adrift in the void. It's a celestial paradox. Most ringed planets like Saturn owe their dazzling halos to the gentle dance of gravity and ice, their orbits stabilized by the warmth of a nearby star. But this rogue, designated Erebus 9, pulses with rings that flare and dim at random, as if powered by some unseen cosmic heartbeat. What could create such a spectacle? The rings themselves are unlike anything in our solar system, composed not just of ice and rock, but laced with metallic compounds that glow faintly in the darkness, like embers in a dying fire. Spectrographic analysis reveals traces of exotic elements, including rare isotopes usually forged in supernova. That's the first clue. Erebus 9 might be a refugee hurled from its birthplace by a cataclysmic event. Imagine a young planet blasted away from its star by a violent collision or the gravitational slingshot of a passing black hole, carrying the shattered remnants of its former system along for the ride. But the real mystery lies in the ring's erratic behavior. Unlike the steady orbits of Saturn's rings, Erebus 9's glow shifts unpredictably, surging in brightness for days before vanishing into near invisibility. Some astronomers theorize the planet's core could be superheated, its magnetic field twisting into knots as it travels through cold interstellar space, sparking electrical discharges that illuminate the debris around it. Others suggest something more exotic, microscopic dark matter particles colliding within the rings, releasing bursts of energy as they annihilate one another. Then there's the eerie possibility that Erebus 9 isn't alone. Tiny gravitational ripples suggest something massive might lurk just beyond detection, an unseen companion, perhaps a brown dwarf or a stealthy black hole, tugging at the planet's rings like a puppeteer. If true, this would rewrite the rules for how rogue planets form, hinting at a hidden population of dark objects drifting unseen through the galaxy. One thing's certain, Erebus 9 challenges our understanding of what a planet can be. Untethered from a star, yet blazing with its own cryptic light, it's a reminder that even in the coldest reaches of space, the universe finds ways to surprise us. Every flicker of its rings is a message in a language we're still learning to decode, a signal from the dark waiting for us to listen. Stretching across a quiet corner of the Small Magellanic Cloud, the hexagonal nebula gleams like a cosmic jewel, its edges so sharp, its angles so exact, it looks less like a cloud of gas and more like an architect's blueprint etched into the void. Nebulae are usually chaotic, wispy things, shaped by the random fury of stellar winds and explosions. But this one defies the chaos, its structure a near-perfect six-sided polygon, as if drawn with a celestial compass. What could possibly carve such precision into something as fluid as interstellar gas? One clue lies in its core, where astronomers have detected a bizarre lattice of magnetic fields, lines of force so strong and orderly, they're bending the nebula's particles into this unnatural geometry. It's as if invisible hands are folding the gas like origami, forcing it into a shape that nature alone wouldn't produce. Normally, magnetic fields in space are tangled and uneven, like a ball of yarn after a cat's played with it. But here, they're aligned with eerie symmetry, as though something or someone tidied them up. Then there's the timing. The hexagonal nebula isn't ancient by cosmic standards, it's practically newborn. Most nebulae take millions of years to form, but this one appeared suddenly, its edges sharpening within decades, a blink of an eye in astronomical terms. Some researchers suggest a freak stellar collision might have unleashed a shockwave so perfectly angled, it sculpted the gas in one explosive instant. Others point to the nebula's uncanny resemblance to theoretical models of energy containment field structures proposed in advanced physics to harness plasma in futuristic reactors. Could this be nature's fluke or something more unsettling? The most tantalizing detail, at the center of the hexagon, there's nothing. No star, no black hole, not even a dense knot of matter, just empty space where the rules seem to rewrite themselves. If it's artificial, what's it for? A beacon, a battery, or perhaps a cosmic accident we're only beginning to decode? The hexagonal nebula doesn't just challenge our understanding of space, it whispers of possibilities we've barely begun to imagine. Deep in the cosmic expanse of the Small Magellanic Cloud, an icy wanderer streaks across the darkness, humming a tune no one expected to hear. The singing comet, a celestial body that doesn't just glide silently through space but broadcasts an eerie harmonic radio chorus as it travels. Unlike typical comets, which whisper only in the faint crackle of solar wind or the occasional burst of static, this one emits a clear, fluctuating sequence of tones, some high and piercing, others deep and resonant, as if strumming the strings of an invisible cosmic harp. Scientists first detected its melody by accident. While scanning the galaxy for pulsar signals, a radio telescope picked up an unusual pattern. Not the steady clicks of a neutron star, but a cascading series of notes, shifting in pitch and tempo with mathematical precision. At first, researchers assumed it was interference, some glitch in the equipment or a rogue satellite. But when they traced the source, they found something impossible. A modest-sized comet, its tail shimmering with ionized gas, pulsing out these radio waves like a celestial transmitter. What could make a comet sing? The leading theory points to its unusually charged tail. As solar radiation ionizes the comet's gases, the particles may be vibrating in sync with the magnetic fields threading through the Small Magellanic Cloud, creating a natural amplifier. Picture wind whistling through a canyon, but instead of air, it's electrified gas resonating across light years. But here's the twist: the harmonics change as the comet nears different celestial objects, suggesting something even stranger. It's almost as if the comet is responding to its environment, its song shifting with the density of interstellar dust or the pull of hidden gravitational forces. Some speculate the comet's core might be laced with rare metallic compounds, acting like a tuning fork for cosmic vibrations. Others wonder if we're hearing an echo effect, a feedback loop caused by the comet's own wake rippling through the galaxy's magnetic field. And then there's the most haunting possibility, that the singing comet isn't just a passive instrument, but an artifact of some long-lost cosmic event, a frozen remnant of a stellar collision or a primordial disruption that imprinted this melody into its very structure. For now, the comet continues its journey, its eerie song drifting through the void. Every note carries data, clues about the magnetic tapestry of the Small Magellanic Cloud, the secrets of ionization, or perhaps something far older. One thing's certain: this isn't just a comet. It's a cosmic musician performing a symphony written by the universe itself, and we're only just beginning to listen. The time-dilated star hangs in the Small Magellanic Cloud like a broken clock, its light flickering not just in brightness, but in the very speed it travels toward us. Normally, starlight is a constant, unwavering stream, governed by the unshakable laws of physics. But this star defies expectation, its photons arriving in sluggish waves for months, then abruptly accelerating as if pushed by some unseen cosmic hand. It's like watching a movie where the playback speeds up and slows down at random, except there's no remote control, just the universe itself bending the rules. What could warp light's behavior so drastically? Einstein's theory of relativity allows for time dilation near massive objects like black holes or neutron stars, where gravity slows time itself. But this star isn't near anything massive enough to explain the effect. Its surroundings are eerily ordinary: no lurking dark matter clumps, no hidden singularities, just empty space. One hypothesis suggests an exotic form of matter might be at play, something dense enough to distort space-time locally but invisible to our telescopes. Picture a cosmic funhouse mirror, one that bends light unpredictably as it passes through, though no such material has ever been observed. Then there's the observational angle. Could our instruments be fooling us? Atmospheric interference or telescope glitches can mimic unusual light behavior, but the time-dilated star's patterns persist across multiple observatories, ruling out local errors. Even stranger, its shifts don't align with any known celestial cycles: no orbiting companion, no pulsating core. The changes are abrupt, almost deliberate, as if the star itself is toggling between dimensions. Perhaps the most unsettling theory involves the fabric of spacetime itself. Some physicists speculate that the star might be grazing the edge of a cosmic defect, a wrinkle in reality left over from the Big Bang, where the laws of physics fray like a worn seam. In such a region, time could flow unevenly, creating pockets where light dawdles or races ahead. It's a radical idea, but if true, this star isn't just an anomaly. It's a window into the universe's hidden architecture, a place where the smooth continuum we take for granted shows its stitches. For now, the time-dilated star keeps its secrets pulsing erratically against the dark. Every flicker is a question, one that challenges our grasp of time, light, and the very foundations of reality. And until we solve it, this celestial enigma will remain a ticking mystery, counting down to an answer we've yet to find. The cosmic jellyfish drifts through the Small Magellanic Cloud like a phantom from the deep sea, a wispy, translucent structure with tendrils stretching across light years, pulsing with faint bioluminescent hues. Unlike the rigid arms of a spiral galaxy or the chaotic knots of a supernova remnant, this formation moves with an eerie fluidity, its filamentary strands rippling as though swayed by invisible currents. At first glance, it resembles a vast plasma discharge, the kind seen looping from the sun's surface, except this one isn't tethered to a star. It floats untethered, a free-floating enigma glowing with energies no one can fully explain. What gives the jellyfish its otherworldly appearance? Its tendrils are threaded with ionized gas, but the patterns defy conventional astrophysics. Instead of dispersing or collapsing under gravity, they coil and uncoil in slow-motion undulations, like a living organism reacting to stimuli. Some sections brighten unpredictably, as if conducting electrical surges across cosmic distances, while others fade into near invisibility, leaving ghostly afterimages in telescope data. The strangest feature, its bell, the dense central region harbors a void, a dark central pocket where sensors pick up nothing. No heat, no light, no detectable matter. It's as if the jellyfish is built around an empty heart. Could this be a new type of plasma structure? Laboratory experiments with superheated gas create similar shapes under controlled conditions, but nothing on this scale, and certainly nothing self-sustaining in the vacuum of space. Alternatively, might it be a cosmic fossil? Some theorists propose that the jellyfish is the aftermath of a hypernova, a star so massive its death throes sculpted the surrounding space into this lingering, delicate form. Yet even that doesn't account for its ongoing dynamism, the way it seems to shift and react to magnetic fields like a celestial anemone. Then there's the most provocative question: could it be alive? Not in the earthly sense, but as a form of primordial, spaceborne life, a colony of self-organizing particles or a macro-scale organism thriving in conditions we barely understand. The idea isn't as far-fetched as it sounds. Scientists have long speculated about life arising in stellar atmospheres or molecular clouds, where complex chemistry might give rise to structures beyond our definition of biology. The jellyfish's rhythmic pulsations, its apparent sensitivity to cosmic rays, even its uncanny symmetry, all hint at a system operating by rules we've yet to decipher. For now, the cosmic jellyfish remains a mesmerizing contradiction, too structured to be random, too vast to be familiar, and too mysterious to categorize. Every observation peels back another layer, revealing not answers, but deeper questions about the line between chaos and order, between accident and design. It's a reminder that the universe doesn't just defy expectations, it invents entirely new ways to leave us in awe. In the silent expanse of the Small Magellanic Cloud, two perfect circles of nothingness hang side by side, the binary void and its mirror twin. These aren't just empty patches of space, they're precise, symmetrical absences, each spanning nearly identical widths, as if someone took a cosmic cookie cutter and cleanly removed two scoops of the universe. Most voids form chaotically, the aftermath of colliding galaxies or drifting gas clouds. But these too, they're geometric, deliberate, their edges so sharp they look like portals to another dimension. What could carve such perfection into the fabric of reality? One spine-tingling theory points to wormholes, hypothetical tunnels through space-time that could link distant regions of the cosmos. If these voids are the mouths of paired wormholes, their symmetry makes eerie sense. Picture two funnels connected by a hidden throat, each opening perfectly aligned to its counterpart. The only problem, wormholes, if they exist, should radiate detectable energy from particle collisions at their edges. Yet these voids give off nothing, no light, no heat, no distortion. Just silence. Another idea suggests something far more unsettling: celestial erasure. Imagine a civilization so advanced it could dismantle stars and planets atom by atom, leaving behind only perfectly clean spheres of emptiness. Or perhaps some natural process, a pair of hyper-advanced black holes, has swept these regions clean, consuming everything in their paths with such efficiency that not even a speck of dust remains. The trouble is, black holes leave traces: accretion disks, gravitational waves, the occasional belch of X-rays. These voids are pristine, as if space itself has been reset to factory settings. Then there's the timing. The twins aren't ancient. Recent observations show subtle shifts in their boundaries, tiny fluctuations that hint at something dynamic beneath the nothingness. Could they be growing, shrinking, or worse, communicating? Some models suggest they might be linked by quantum entanglement, their empty states perfectly correlated across light years, changing in unison despite no visible connection. The binary void and its twin don't just defy explanation, they mock it. Every theory scientists propose crumbles under scrutiny, leaving only the chilling possibility that we're staring at something entirely new. Whether they're cosmic accidents, alien artifacts, or cracks in reality itself, one thing's certain: these twin voids are a riddle wrapped in nothingness, floating in the dark, waiting for us to unravel their secrets. Among the strangest formations in the Small Magellanic Cloud, 3 radiant points form a perfect equilateral triangle, each vertex pulsing with identical intensity, as if set there by cosmic design. The triangulum anomalies don't just catch the eye, they defy logic. Most celestial alignments are random, the temporary dance of stars drifting through space. But this trio, their positions are mathematically precise, locked into a symmetry so exact, the odds of it occurring naturally are astronomically slim. Start with the light itself. Each anomaly emits the same peculiar frequency, a blend of ultraviolet and infrared radiation, as if tuned to the same invisible channel. Even more perplexing, their brightness fluctuates in perfect unison, dimming and flaring at intervals that mirror one another down to the millisecond. It's like watching 3 lighthouses on different continents somehow flashing in flawless sync. Natural objects don't behave this way. Stars twinkle independently, pulsars follow their own rhythms. So what could link these points across light years of space? One explanation points to gravitational lensing, a phenomenon where massive objects bend light, creating duplicate images of a single source. If an ultra-dense object like a black hole sat precisely between us and the anomalies, it might warp their light into this triplicate pattern. But here's the catch: no such lensing object has been found, and the anomalies' spectra don't match. They're not reflections or mirages. Each emits distinct elemental signatures, proving they're 3 separate entities. Then there's the artificial angle. Could these be markers, beacons left by an advanced civilization to map the galaxy or signal their presence? The triangle's precision echoes humanity's own use of geometric patterns in navigation, from ancient stone circles to GPS satellites. If intentional, their uniformity might encode information, a sort of interstellar QR code etched into the fabric of space. Skeptics argue nature rarely needs a ruler to create order. but proponents counter with examples like the hexagonal storms on Saturn, proof that geometry can emerge spontaneously under the right conditions. But the most chilling possibility, they're not markers at all, but anchors. Some theorists suggest the anomalies could be stabilizing a larger structure, a hidden dimensional fold, or a cloaked megastructure we can't yet perceive. Imagine a tent pegged down at 3 points. These glowing vertices might be holding something unimaginably vast in place, their light the only hint of forces at work beyond our comprehension. For now, the triangulum anomalies remain a riddle wrapped in perfect symmetry. Whether natural marvel or something far more profound, their existence challenges us to rethink the boundaries of coincidence and wonder what other shapes might be hidden in the dark, waiting to be decoded. The metallic moon floats in the Small Magellanic Cloud like a discarded cosmic mirror, a perfectly smooth, spherical object the size of a small moon, its surface reflecting starlight with an almost painful brilliance. Unlike pockmarked natural satellites or dusty asteroids, this anomaly has no craters, no mountains, no visible flaws. It's as if someone took a celestial lathe to it, polishing it to a chrome-like finish that throws back the surrounding cosmos with near-perfect fidelity. Peer at it through a telescope and you're not just seeing a moon, you're seeing a distorted funhouse reflection of the universe itself. What makes this so unsettling? Natural celestial bodies don't form this way. Even the smoothest known objects, like Jupiter's ice-covered moon Europa, still bear the scars of impacts and tectonic shifts. But the metallic moon's surface is unnervingly pristine, reflecting 98% of all light that hits it, a reflectivity rate surpassing even the most polished human-made mirrors. Chemical analysis reveals its shell isn't just metal. It's an alloy unlike anything found in nature, a blend of iron, nickel, and an unidentified element that resists spectral classification. Some researchers joke it's stainless space steel, but the truth is far stranger. Could it be artificial? The moon's orbit adds fuel to the fire. Instead of following a predictable elliptical path, it drifts lazily through a dust-free corridor of space, as if maneuvering to avoid collisions. Even more bizarre, its reflectivity isn't passive. During a solar flare event last year, telescopes caught the moon briefly brightening not from reflected light, but from some internal response, as if its surface had activated to absorb and re-emit energy. Moments later, it dimmed again, settling back into its usual eerie glow. Theories range from the plausible to the fantastical. One camp argues it's the remnant of an ancient, hyper-advanced civilization's megastructure, a long-abandoned solar mirror or communication relay frozen in time. Others propose a natural explanation, a rare, quenched planetesimal, a protoplanet that cooled so rapidly in the early universe its crust formed a single, unbroken metallic sheet. But the most mind-bending idea, that it's not a moon at all but a probe, a dormant, self-repairing machine, perhaps millions of years old, silently observing the galaxy with its mirrored face. The chilling truth we may never know. The metallic moon doesn't just defy classification, it mocks it. Every scan, every spectral reading, every attempt to explain its origin only deepens the mystery. For now, it hangs in the void, a perfect silver enigma, reflecting our own unanswered questions back at us. The flare dragon slithers through the Small Magellanic Cloud like a sleeping beast roused from its lair, a vast, twisting ribbon of superheated plasma that stretches across light years, flickering to life with eerie predictability. Every 72 years, like clockwork, this cosmic serpent awakens, its sinuous form erupting in violent bursts of X-rays and gamma radiation that illuminate the surrounding void like a celestial flare. Most stellar phenomena operate on chaotic timescales, governed by the messy interplay of gravity and nuclear reactions. But the flare dragon's rhythm is unnervingly precise, as if set by some invisible cosmic metronome. What could possibly fuel such periodic fury? One clue lies in its structure. The dragon isn't just a loose trail of gas, it's a coherent filament, its ionized particles bound together by magnetic fields so intense they act like a cage for the energy within. Spectrographic readings reveal elements typically forged in the cores of dying stars: neon, magnesium, even traces of gold. This suggests the dragon might be the remnant of a colossal stellar explosion, a supernova so powerful it didn't just scatter debris, it sculpted it into this lingering, volatile form. But the real mystery is the timing. 72 years isn't a random interval. In astrophysics, such regularity usually points to an orbital dance, perhaps a neutron star or black hole swinging close enough to the filament to trigger a release of pent-up energy. Yet scans show no such companion. Instead, researchers have detected faint gravitational ripples along the dragon's length, subtle distortions in spacetime that hint at something even stranger, a cosmic string. These hypothetical threads, thinner than an atom but denser than a neutron star, are relics of the early universe, theorized to stretch across the cosmos like cracks in frozen ice. If one slices through the Small Magellanic Cloud, it might be vibrating periodically, agitating the dragon's plasma like a bow drawn across a violin string. Then there's the artificial angle. Could this be a dormant stellar engine, a megastructure built by an ancient civilization to harness energy? The dragon's flares release enough power to light 1,000 stars, their spectra oddly uniform, lacking the chaotic signatures of natural eruptions. Some models suggest its plasma might be confined in a magnetic bottle, a technology far beyond our grasp but theoretically possible for an advanced society. If true, the dragon could be a forgotten power source, cycling through its pre-programmed routine long after its builders vanished. Yet the most haunting possibility is that we're witnessing a cosmic coincidence, a perfect storm of physics and geometry that creates this illusion of intention. The universe is vast enough for even the rarest phenomena to occur, and the flared dragon might simply be nature's masterpiece, a celestial clockwork we're only now learning to read. Whatever the truth, its next awakening is already on the calendar. Telescopes across the globe will turn toward it, hoping to catch clues in its fiery breath. Will it reveal the hand of intelligence, the fingerprints of the cosmos, or something beyond our current imagination? The flared dragon keeps its secrets close, coiled in the dark, waiting for its moment to blaze again. The Quantum Quasar pulses at the heart of the Small Magellanic Cloud like a glitch in reality itself, a radiant object where the laws of physics seem to short-circuit. Unlike ordinary quasars, which blast energy in predictable jets, this one flickers with particles that behave as if they exist in two places at once, defying the very notion of cosmic certainty. When telescopes train on it, they capture photons arriving from opposite sides simultaneously, their paths impossible to reconcile without invoking quantum weirdness on a galactic scale. It's as if the quasar's core is running a cosmic double exposure, superimposing multiple states of existence across light years of space. What could cause such bizarre behavior? The answer might lie in the quasar's monstrous engine, a supermassive black hole spinning at near light speed, warping spacetime so violently that it creates a natural laboratory for quantum effects. Normally, quantum superposition, the phenomenon where particles exist in multiple states until observed, plays out at subatomic scales. But here, the extreme gravitational forces may be amplifying these effects, stretching them into the macroscopic realm. Imagine tossing a coin and seeing it land as both heads and tails, but instead of a coin, it's an entire stream of high-energy particles, each one refusing to choose a single path. Even stranger, the quasar's emissions exhibit quantum entanglement, a ghostly connection where particles instantaneously influence each other, no matter the distance. When one photon flares brighter, its twin on the opposite side mirrors the change within picoseconds, faster than light could traverse the gap. Einstein famously called such behavior spooky action at a distance. yet the quantum quasar flaunts it openly as if taunting our attempts to explain it. Some theorists suggest the black hole's accretion disk might be threaded with cosmic strings, hypothetical defects in spacetime that act as quantum highways linking distant points without regard for classical physics. Others propose the quasar's core could harbor exotic matter, a form of particle that operates outside standard models, rewriting the rules of cause and effect. The implications are staggering. If quantum phenomena can scale up to celestial sizes, it challenges everything we thought we knew about the universe's fabric. Could black holes be natural quantum computers processing information in ways we can't yet fathom? Might the quasar's flickering light be a side effect of parallel realities brushing against our own? Every observation deepens the mystery, revealing not just a cosmic oddity, but a window into the universe's most profound secrets. For now, the quantum quasar keeps its riddles close, shimmering with possibilities. Each pulse is a question, one that might hold the key to unifying quantum mechanics and gravity, or perhaps something even more extraordinary. Until we decipher its code, this radiant enigma will continue to blur the line between the impossibly small and the unimaginably vast. The fossilized supernova lingers in the Small Magellanic Cloud like a cosmic photograph. An explosion frozen mid-blast, its shockwaves arrested in a shimmering tableau of glowing filaments and twisted metal. Most supernova remnants expand and fade over millennia, their energy dissipating into the void. But this one, it's caught in a single, eternal moment, as if someone pressed pause on a stellar detonation 10,000 years ago. Peer through a telescope and you're not seeing echoes of the past, you're witnessing the event itself, preserved in perfect, terrifying detail. What could trap a supernova in time? The answer might lie in the remnant's bizarre magnetic field, an invisible web of force so dense it acts like amber encasing an insect. Spectrographic scans reveal the plasma here isn't just cooling, it's locked in place, its particles vibrating but never drifting apart. Some researchers compare it to a cosmic flytrap where magnetic threads snare the explosion's energy mid-flight, preventing it from escaping. Imagine lightning captured in a bottle, but instead of glass, the container is woven from the fabric of spacetime itself. Then there's the composition. The filaments are laced with neutron-rich isotopes, heavy elements typically forged in supernova cores, but they're arranged in layered rings, like tree rings marking the explosion stages. Normally, these elements would scatter chaotically, yet here they're stacked with eerie precision, as if the supernova's final microseconds were catalogued atom by atom. One theory suggests an outside force intervened, perhaps a passing rogue black hole's gravity warped the blast wave into this unnatural stillness. Others propose something even stranger, that the remnant isn't frozen at all, but trapped in a time dilation bubble where seconds stretch into eons from our perspective. The most unsettling possibility, this isn't a fossil, it's a snapshot. Some models hint that the supernova might still be unfolding within its own distorted spacetime, its light and energy ricocheting in an endless loop. If true, we're not looking at a dead star, we're peering into a celestial zoetrope where the same cataclysm replays forever, just beyond our grasp. Whether it's a quirk of physics or a crack in time's arrow, the fossilized supernova refuses to fade. It hangs in the void, a monument to a detonation that never quite ended, challenging us to decipher whether we're seeing history or something far more alive. The gravity lens paradox twists the Small Magellanic Cloud into a celestial hall of mirrors, a place where stars don't just shine, they multiply. Peer into this region, and you'll catch the same star repeated 5, 10, even 20 times across the darkness, each copy shimmering at slightly different angles as if space itself has been crumpled like a piece of reflective foil. Gravitational lensing isn't new. Massive objects like galaxies or black holes often bend light, creating cosmic mirages, but here the effect spirals into the absurd. There's no single massive object warping the light, just a diffuse patch of space where gravity seems to stutter, bending rays into knots without any visible cause. What could possibly explain this? Start with the duplicates themselves. Unlike typical lensed images where a background star might appear as a neat ring or twin smudges, these repetitions scatter chaotically. Some glow brighter than the original, as if amplified by unseen lenses. Others flicker out of sync, their light arriving years apart despite originating from the same source. It's like looking at a disco ball where every mirror facet shows a different moment in time. Astronomers first blamed a hidden cluster of dark matter, an invisible scaffold tugging at spacetime. Yet simulations fall short. No arrangement of dark matter explains the lensing's sheer complexity or the way certain images warp into shapes resembling stretched taffy. Then there's the timing problem. Light from these duplicates should follow predictable delays dictated by the extra distance traveled around a gravitational curve. But some arrive too early, as if they've taken shortcuts through space. This has led to wilder theories, microscopic wormholes threading the area, or quantum foam, a froth of subatomic spacetime fluctuations acting like a prism for gravity itself. Picture a mountain pass riddled with secret tunnels. Light might take the long road around or slip through a hidden fracture and emerge ahead of schedule. The most unsettling possibility, we're seeing the aftermath of a cosmic collision, not between stars or galaxies, but between dimensions. Some models suggest a higher dimensional brain, a membrane-like structure from string theory, might have brushed against our universe here, leaving behind wrinkles in gravity's fabric. These wrinkles could act as lenses within lenses, folding light in ways that defy three-dimensional logic. If true, the paradox isn't just a puzzle, it's a graffiti tag left by physics we can't yet perceive, a message scrawled in the language of warped spacetime. For now, the gravity lens paradox remains a hall of mirrors without a guide. Every duplicate image is a clue and a taunt. Untangling this mess might require more than new telescopes. It could demand rewriting the rules of gravity itself. Until then, the stars keep multiplying, laughing at our confusion from their fractured reflections. Amidst the glittering expanse of the Small Magellanic Cloud, two unassuming stars play the ultimate cosmic game of hide and seek the phantom dwarfs. These aren't your typical twinkling lights. They're master escape artists, fading from view for years at a time before blinking back into existence as if nothing happened. Most variable stars dim and brighten predictably, but these two defy all patterns, vanishing so completely that even our most sensitive instruments can't detect a trace of them. No heat signatures, no gravitational wobbles, just empty space where a star should be. What could make an entire star disappear? One explanation sounds straight out of science fiction: cloaking technology. Imagine an advanced civilization constructing massive energy shields or refraction fields around these dwarfs, bending light around them like an interstellar invisibility cloak. While it's a tantalizing thought, nature might have its own tricks up its sleeve. Some astronomers suggest these stars could be shrouded in ultra-dense clouds of dust or exotic matter, particles so efficient at absorbing light that they render their host stars temporarily invisible. Yet even that theory struggles to explain how the dwarfs reappear without scattering any debris, like a magician's assistant stepping back onstage without a single ruffled feather. Then there's the wilder possibility: dimensional shifts. If these stars exist near unstable regions of spacetime, they might periodically slip into other dimensions or parallel branes, vanishing from our observable universe before snapping back into place. Think of a boat bobbing on choppy waves. Sometimes it dips below the surface, only to reappear moments later. The math behind higher dimensional physics allows for these kinds of transitions, though we've never observed them on such a scale. The strangest clue: when the phantom dwarfs return, they're never quite the same. Spectral analyses show subtle shifts in their elemental composition, as if they've aged differently during their absence or absorbed traces of something beyond our detection. One even emitted a brief pulse of structured radio waves upon reappearing, a signal that, while likely natural, sent a ripple of excitement through the SETI community. Whether they're cosmic chameleons, dimensional travelers, or something beyond our current theories, these two stars challenge our understanding of what celestial objects can do. Every time they vanish, they take a little piece of our certainty with them, only to return, silent and enigmatic, daring us to solve their riddle before the next disappearance. The blood-red reef sprawls across the Small Magellanic Cloud like a wound in the cosmos, a vast, intricate structure of crimson gas filaments, twisting and branching like some alien coral colony frozen in zero gravity. Unlike the soft pastels of typical nebulae, this one burns with a deep, rust-colored hue, as if the universe itself is hemorrhaging iron into the void. Peer through a telescope and you'll swear the tendrils pulse faintly, their edges diffusing into space like ink dropped into water, staining the darkness with their eerie glow. What gives this nebula its unsettling color? The answer lies in its composition, an unusually high concentration of ionized iron, atom by atom stripped of electrons and set ablaze by nearby stellar radiation. Most nebulae glow from hydrogen or oxygen, painting the cosmos in ethereal blues and pinks. But here, iron dominates, its spectral signature painting the gas cloud in shades of ochre and crimson. It's as if a dying star vomited its metallic guts across the void, leaving behind this sprawling, rusted monument. Some researchers joke it's space's version of a chemical spill, but the truth is far more violent. The iron likely came from a supernova's heart, forged in the final moments of a massive star's collapse before being hurled outward in a catastrophic explosion. Yet the reef isn't just a graveyard, it's a nursery. Nestled within its bloody tendrils, new stars flicker to life, their ultraviolet radiation ionizing the surrounding iron and making the entire structure glow even brighter. It's a paradox, the same element that signals stellar death here fuels stellar birth, the iron acting as a cosmic fertilizer for the next generation of suns. Over eons, these young stars will devour the remaining gas, their light bleaching the reef back into obscurity. But for now, it bleeds into the darkness, a reminder that even in destruction, the universe finds ways to create. The most haunting detail, the reef isn't static. Spectrographic scans reveal the iron isn't just sitting there, it's migrating, drifting outward into interstellar space at speeds that defy simple stellar winds. Some unseen force, perhaps a hidden neutron star or a rogue magnetic field, is stirring the gas, sending tendrils spiraling light years beyond their origins. It's as if the nebula is reaching out, staining everything it touches with its metallic signature. Whether it's a relic of a dead star or the cradle of new ones, the blood-red reef stands as one of the most vivid oddities in the Small Magellanic Cloud. A place where the cosmos bleeds iron, where death feeds life, and where the line between destruction and rebirth blurs into a single, crimson question mark. The clockwork pulsar ticks through the Small Magellanic Cloud with a precision that borders on unsettling, its pulses arriving in intervals so exact you could set your watch by them. Most pulsars, the spinning remnants of dead stars, flicker with tiny hiccups in their rhythm, their rotations gradually slowing as they bleed energy into space. But this one, its beats land like the pendulum swings of a grand cosmic clock, each burst of radiation hitting its mark down to the nanosecond, never wavering, never faltering. It's as if the universe itself has a heartbeat, and somewhere in the void it's keeping perfect time. What could explain such flawless timing? Normally, a pulsar's spin is governed by chaotic forces, clumps of matter falling onto its surface, magnetic fields tangling and snapping, even tremors in its crust called starquakes. Yet the clockwork pulsar shows none of these quirks. Its rotation is smoother than any natural object has a right to be, as if some unseen hand has sanded away the imperfections, leaving behind a celestial timepiece. Some scientists argue it might be the product of an extremely rare stellar collapse, where the dying star's core crystallized into a near-perfect sphere, eliminating any wobble in its spin. Others suggest it's locked in an orbital dance with an invisible companion, a dwarf star or black hole whose gravity acts like a regulator, fine-tuning the pulsar's rhythm like the weights in a grandfather clock. But then there's the more provocative theory that this isn't natural at all. The pulsar's radio emissions carry an odd uniformity, their frequencies clustering in narrow bands that resemble engineered signals more than the usual cosmic static. Could this be a beacon, a navigation marker left by an ancient civilization, or even a piece of dormant technology far beyond our understanding? The idea isn't as far-fetched as it sounds. Pulsars are already nature's lighthouses. They're predictable flashes used by astronomers to map the galaxy. An advanced society might have taken that concept further, sculpting a pulsar into something even more precise, a cosmic chronometer or a message in Morse code written across light years. Yet the most spine-tingling possibility is that we're witnessing a new law of physics in action. What if, under extreme conditions, matter can achieve a state of near-perfect equilibrium, spinning without friction or decay? The clockwork pulsar might be a freak occurrence, a glimpse into a regime where the chaos of the cosmos briefly surrenders to order. Every pulse is a clue, a tick on a cosmic stopwatch counting down to a revelation we're only beginning to grasp. For now, the clockwork pulsar keeps its secrets ticking away in the dark with inhuman precision. Whether it's a masterpiece of nature, a relic of intelligence, or something beyond both, one thing's certain: it's a reminder that even in the vast, unruly universe, there are pockets of perfection waiting to be found. The hollow asteroid drifts through the Small Magellanic Cloud like a cosmic coconut, its rocky shell perfectly intact, but its inside scooped out with surgical precision. At first glance, it looks like any other space rock tumbling silently through the void. But when astronomers pinged it with radar, the echoes told a different story. This asteroid isn't solid. It's a husk, a celestial matryoshka doll with a cavernous interior so vast you could fit a small moon inside, and the strangest part, the inner walls are polished smooth, as if sanded down by some unimaginable force. How does something like this form? Normally, asteroids are jagged, pockmarked rubble piles, the leftover debris of planetary formation. Even the rare metallic ones show signs of bombardment or stress fractures. But this object's interior is eerily flawless, with no telltale cracks or impact scars. One theory suggests it might be the remnant of an ancient mining operation. Imagine a long-vanished civilization hollowing out the asteroid for resources, stripping its core of precious metals or volatile compounds before abandoning it to the cosmos. The smooth walls could be the marks of advanced machinery, or even the residue of some now extinct industrial process. It's a tantalizing thought, but without physical evidence, it remains pure speculation. Yet nature has its own ways of carving voids. Some researchers propose the asteroid might have once been packed with volatile ices that sublimated away over eons, leaving behind an empty shell. Others point to tidal forces. A close encounter with a neutron star or black hole could have sucked out its innards like a cosmic straw, leaving only the hardened crust behind. There's even a wilder idea that the hollowing was caused by a subatomic vacuum decay event, where a bubble of unstable spacetime briefly touched the asteroid, erasing its interior without a trace. Then there's the mystery of its orbit. The hollow asteroid doesn't drift aimlessly. It follows an unnaturally stable path, as if positioned deliberately. Could it be a hidden way station, a relic of some interstellar trade route lost to time? Or is its trajectory just a fluke of celestial mechanics, a roll of the dice that placed it where it is? One thing's certain: this isn't just a rock. It's a riddle wrapped in stone, floating silently through the dark. Whether it's a natural oddity or something far more profound, the hollow asteroid dares us to reconsider what secrets might lurk inside even the most unassuming objects in the sky. The whispering trio drifts silently through the Small Magellanic Cloud, broadcasting signals that defy explanation, 3 radio sources locked in a cryptic conversation no one can understand. Unlike the natural static of pulsars or the chaotic noise of quasars, these emissions arrive in precise, repeating sequences, their pulses arranged in patterns so intricate they resemble linguistic syntax more than cosmic static. Discovered decades apart, the trio's signals were initially dismissed as equipment glitches until astronomers realized they were hearing the same voice from 3 distinct points in space, each transmission offset by exact intervals like clockwork chimes ringing across the void. What makes these signals so unsettling starts with their structure. Most cosmic radio waves scatter randomly, but the trio's pulses cluster into distinct groupings, bursts of 5, then 7, then 12, mirroring prime numbers, a sequence that famously caught Carl Sagan's attention in his novel Contact. Even stranger, the gaps between bursts aren't arbitrary. They follow Fibonacci ratios, a mathematical pattern found in nature from sunflower seeds to spiral galaxies. SETI researchers have spent years running these sequences through every decoding algorithm imaginable, hunting for hidden meaning. Could it be a beacon, a distress call, or something far more obscure like a cosmic Rosetta Stone left by intelligence beyond our own? Then there's the synchronization. Despite being light years apart, the trio's signals align with eerie precision, as if orchestrated by some unseen conductor. When one source falters, skipping a pulse or shifting frequency, the others adjust within hours, compensating in ways that suggest real-time coordination. This isn't just mimicry, it's a dialogue. The leading theory, gravitational lensing, might be bending spacetime to create echoes, but no known lensing object explains the timing or the trio's ability to respond to shifts. The most chilling possibility isn't just that the signals are artificial, it's that they're old. Based on the light travel time, these transmissions could have begun over 100,000 years ago, meaning whatever crafted them might be long gone. The trio's whispers could be the last echoes of a civilization that flared bright and vanished, their messages still looping through the cosmos, waiting for someone or something to finally listen. Whether they're a natural fluke, a monument to lost minds, or something beyond our current science, one thing's clear: the whispering trio refuses to be ignored. Every pulse is a riddle wrapped in static, a cosmic Morse code we're only beginning to trace. And until we crack their cipher, they'll keep murmuring in the dark, a conversation just out of reach. The Eclipse engine pulses in the depths of the Small Magellanic Cloud like a cosmic dynamo, a binary star system where eclipses don't just dim the light, they unleash torrents of energy so intense they outshine both stars combined. Picture 2 celestial bodies locked in a close, furious orbit, their dance so precise that every time one passes in front of the other, the system erupts in a blaze of X-rays and gamma radiation, as if flipping a hidden switch in the universe. Most eclipses are silent affairs, momentary shadows, but here darkness sparks fireworks, what could turn a simple alignment into a cosmic power surge. The answer might lie in the stars themselves. The larger of the two is a volatile blue giant, its surface roiling with magnetic storms, while its smaller companion is a dense, fast-spinning neutron star, a remnant of a supernova packed with unimaginable energy. Normally, their eclipses would block light, not amplify it, but the neutron star's immense gravitational field acts like a cosmic magnifying glass, bending and compressing the blue giant's radiation during each eclipse, focusing it into a concentrated beam that flares across the electromagnetic spectrum. It's as if the system has built-in lenses, turning a routine celestial event into a natural particle accelerator. Yet there's a twist that has scientists whispering about more exotic possibilities. The energy surges don't just spike randomly, they follow a precise, repeating sequence, each eclipse triggering a pulse pattern that mirrors theoretical models for controlled fusion reactions. Some researchers argue this could be evidence of a naturally occurring stellar engine, a rare alignment of physics that transforms the binary pair into a self-regulating power plant. Others go further, suggesting the patterns are too orderly, too optimized to be purely natural. Could the eclipse engine be a tapped resource, its energy harvested by some advanced civilization long gone? Ancient Dyson swarm remnants or megastructural fragments could, in theory, still linger in the system, activated only when the eclipse's unique conditions are met. Then there's the timing. The surges aren't just powerful, they're predictable down to the millisecond, as if the entire system is governed by an invisible clock. Natural processes are rarely this exact, raising the spine-tingling question. Is this a cosmic coincidence or a designed phenomenon? The debate rages, but one thing's certain. The eclipse engine defies easy categorization. Whether it's nature's masterpiece or a relic of something far more profound, each eclipse is a reminder that even the most familiar celestial events can hide universe-altering secrets. The celestial monolith drifts through the Small Magellanic Cloud like an abandoned skyscraper from another universe, a stark, rectangular slab of blackened metal, its edges so unnaturally straight they seem etched by an architect's hand rather than cosmic chaos. Most asteroids and debris in space tumble in irregular shapes, worn smooth by eons of collisions. But this object defies expectation, its flat surfaces reflecting starlight in precise geometric patterns as if polished to an impossible finish. At roughly 12 kilometers long and 4 wide, it dwarfs anything humans have ever constructed, yet its proportions echo the eerie symmetry of fictional monoliths from science fiction. It's the kind of object that makes astronomers double-check their instruments, wondering if they've stumbled onto something beyond natural explanation. What could carve such perfection into the void? The monolith's composition deepens the mystery. Spectral scans reveal a metallic alloy unlike any known in nature, a dense lattice of iron, nickel, and an unidentified element that absorbs electromagnetic waves rather than reflecting them. It doesn't just appear black, it devours light, rendering its surface eerily featureless even under the closest scrutiny. Some researchers joke it's the universe's first stealth spaceship, but the truth is far stranger. The monolith isn't orbiting or moving with intent. It simply drifts indifferent to gravity's pull, as if anchored to some invisible framework beyond our perception. Then there's the thermal anomaly. Despite floating in the freezing vacuum of space, the monolith emits faint, rhythmic pulses of heat, not from radiation or external heating, but from within, as if harboring some dormant energy source. Every 27 hours exactly, its temperature spikes by a fraction of a degree, a pattern so precise it resembles a heartbeat. Natural objects don't behave this way. Metals cool uniformly in space. They don't flicker like a machine cycling through dormant protocols. Could this be some ancient device, a relic of a long-extinct civilization's technology, still ticking away after millennia? Or is it a natural phenomenon we've never encountered, a strange byproduct of quantum condensation or magnetic crystallization? The most unsettling detail, though, is its silence. The monolith doesn't just resist explanation, it refuses to interact with its environment at all. Probes sent to scan it bounce back distorted data, their sensors overwhelmed by bizarre interference patterns. Attempts to map its surface with lasers return blurry, fragmented images, as if the very act of observation distorts reality around it. Some theorists suggest it might be encased in a localized warp field, a bubble of altered space-time that scrambles all attempts to study it directly. Others whisper about the possibility of it being a tabula rasa, a blank slate intentionally designed to reflect the expectations of whoever discovers it, a cosmic Rorschach test hanging in the void. Whether it's a monument, a machine, or something beyond our current physics, the celestial monolith stands as one of the most confounding enigmas in the Small Magellanic Cloud. It doesn't just defy categorization, it challenges the very way we think about structure, purpose, and the limits of natural law. Every scan, every theory, every sleepless night spent pondering its origins only leads to more questions. And until we uncover the truth, it will keep drifting silent, perfect, and utterly indifferent to our curiosity. The storm egg looms in the depths of the Small Magellanic Cloud like a cosmic womb gone haywire, a dense, oval maelstrom of gas and plasma, its surface alive with forks of lightning that arc across its shell with unnerving regularity. Most stellar nurseries are chaotic but predictable, their turbulence birthing stars over eons. This one, though, crackles with something stranger, as if it's not just forming stars but containing them, trapping their furious energy behind a shimmering electric veil. At first glance, it resembles a thunderhead from a nightmare, a swirling mass of ionized particles lit from within by bursts of blue-white energy, but scale warps the familiar into the uncanny. The egg spans nearly half a light-year, its lightning strikes carrying enough power to vaporize planets, each bolt a jagged scar across the darkness. Spectrographic scans reveal heavy elements like silicon and sulfur lacing its outer layers, the telltale debris of previous stellar explosions locked in a constant cycle of destruction and rebirth. It's as if the egg is feeding on its own chaos, recycling the remains of dead stars to fuel whatever lurks inside. And that's the real mystery: what is inside? The egg's core is impenetrable to most sensors, its dense plasma shell scattering radiation like a cosmic Faraday cage. Some theories suggest it's a failed star, a brown dwarf that never quite ignited, its aborted fusion reactions manifesting as these endless electrical storms. Others propose it's something far more active, a protostellar prison, where nascent suns spiral in a gravitational dance too unstable to sustain, their collisions unleashing the egg's furious lightning. Then there's the timing. Unlike normal stellar nurseries where star formation unfolds over millions of years, the egg's tantrums follow a rhythm. Every 11 months, its lightning activity spikes, the bolts converging toward the center before vanishing altogether for exactly 48 hours. A lull so precise it feels orchestrated. During these pauses, infrared telescopes catch faint heat blooms deep within, as if something is breathing in the heart of the storm. Could this be nature's way of incubating stars under extreme conditions? Or is the egg something else entirely, a containment field for energies we don't yet understand? Some models even speculate it might be a natural particle accelerator, its lightning acting as cosmic slingshots, hurling matter to near light speeds. If true, the egg isn't just a curiosity, it's a factory for rare high-energy particles, a place where the universe bends its own rules. For now, the storm egg keeps its secrets crackling with defiance. Every bolt is a question, every lull a tease. Whether it's a stellar cradle, a cosmic battery, or something beyond our current science, one thing's clear: this isn't just a cloud. It's a tempest with a purpose, and we're only beginning to decipher its furious language. The fractal galaxy spins in the Small Magellanic Cloud like a celestial snowflake, a tiny, intricate structure where the same patterns repeat at every scale, defying the universe's usual preference for chaos. Most galaxies sprawl in sprawling arms or elliptical blurs, their shapes blurred by gravity's messy tug-of-war. But this one, zoom in, and you'll find spirals within spirals, delicate tendrils branching into identical smaller versions of themselves, a cosmic Russian nesting doll carved from starlight. It's as if someone took a galaxy and folded it into an infinite cosmic origami, where the rules of size and hierarchy simply don't apply. What makes this so baffling? Start with the sheer improbability. Fractals, self-repeating mathematical patterns, are common in nature from fern leaves to coastlines, but they're not supposed to govern entire galaxies. The universe operates on scale laws. What works for a dust grain doesn't apply to a star cluster, yet here the fractal galaxy laughs at those rules. Its tiniest curls, barely wider than a solar system, mirror the grand arcs of its outermost arms, all rotating in eerie synchrony. Imagine a whirlpool where every droplet spins in perfect miniature replica of the whole. This is the level of precision we're dealing with. Theories scramble to explain it. One camp argues for an exotic form of dark matter, a sticky variety that clumps in fractal waves rather than smooth halos, sculpting the visible stars into these cascading layers. Others point to a freak gravitational resonance, perhaps an ancient collision with another galaxy sent shockwaves through its structure, locking it into this self-replicating dance. But the most mind-bending idea, that the fractal galaxy isn't a stable structure at all, but a snapshot of a galaxy mid-unfolding, caught in the act of transitioning between states. Picture a piece of paper crumpled and partially smoothed. The creases linger, echoing the original chaos. If true, we're witnessing a cosmic metamorphosis frozen in time. Then there's the observation problem. Fractals are infinite in theory, but telescopes have limits. Every time we upgrade our instruments, new layers of the galaxy's pattern emerge, smaller and fainter than before. Where does it end? Is there a base unit, a smallest spiral, or does the recursion continue down to the atomic scale? Some models suggest the galaxy might be a natural quantum hologram, its large-scale structure encoding information about its smallest parts, a living example of as above, so below. The implications are staggering. If nature can craft a fractal galaxy, what else might be possible? Could entire universes nest inside one another? Are we, too, part of some unfathomable larger pattern? The fractal galaxy doesn't just challenge astrophysics, it whispers of a universe far more interconnected, far more artful than we ever imagined. Every spiral is a question, every repeating curve a clue, daring us to rethink the very fabric of reality. The diamond veil shimmers in the Small Magellanic Cloud like a celestial jewel box, a vast, swirling cloud of interstellar dust, except this isn't just any cosmic debris. Every speck glints with the telltale signature of crystallized carbon, a trillion microscopic diamonds suspended in the void, catching starlight and scattering it into prismatic halos. Most cosmic dust consists of silicates or sooty graphite, but this cloud is different. It's a floating trove of gemstones stretching across light years, its composition so pure that if you could scoop up a handful, it would glitter like powdered stardust in your palm. How does something so extravagant form naturally? The answer lies in the corpses of stars. When certain carbon-rich suns die, they don't explode in supernova. They exhale their outer layers in slow, luminous waves, leaving behind planetary nebulae laced with carbon atoms. In the cold, high-pressure depths of these stellar winds, those atoms can bond into crystalline lattices, forging nanodiamonds by the sextillion. Normally, these particles disperse into the galactic background, invisible to telescopes. But the diamond veil is different. Here, some cosmic fluke, perhaps a collision with another nebula or the gravitational nudge of a passing star, has concentrated them into this shimmering river of gemstones, a frozen echo of some ancient star's final breath. But the real mystery isn't just their abundance, it's their size. Most stardust diamonds are microscopic, no larger than a virus. Yet spectral analysis hints at outliers in the veil, crystals potentially big enough to see with the naked eye. Picture diamond pebbles adrift in space, tumbling silently through the dark. How they grew so large without clumping into asteroids or shattering in collisions is a puzzle. Some theories suggest magnetic fields might be herding them, aligning the grains like iron filings to prevent chaos. Others propose the veil is younger than we think, its diamonds freshly formed and not yet worn down by time. Then there's the question of destiny. Left undisturbed, the veil's diamonds will eventually spiral into new stars or planets, their carbon becoming the bedrock of future worlds. Imagine a planet someday forming from this glittering reservoir, its very soil laced with stardust diamonds, its mountains potentially capped with gemstone glaciers. It's a reminder that the universe doesn't just create life's ingredients, it sometimes crafts them with breathtaking extravagance. For now, the diamond veil drifts, a testament to the cosmos's hidden artistry. Every sparkle is a whisper from a dead star, a promise that even in the cold void there's beauty waiting to be found if you know where to look. The Lighthouse Nebula pierces the darkness of the Small Magellanic Cloud like a cosmic beacon, its swirling gases not just glowing, but projecting razor-thin beams of light in perfect parallel lines, as if the universe itself were sending Morse code across the void. Most nebulae scatter their radiance in all directions, painting the cosmos with soft, ethereal brushes. But this structure defies the norm, its light organized into disciplined shafts that stretch for light years without dispersing, illuminating distant dust clouds like spotlights on a celestial stage. What could possibly focus light with such precision? Nature's answer might lie in Maser's natural microwave lasers formed when molecules like water or methanol become energetically excited, emitting coherent light rather than the usual chaotic glow. Across the universe, masers often occur in star-forming regions, flickering faintly. But the Lighthouse Nebula takes this phenomenon to extremes, amplifying its beams to visible wavelengths with intensities that rival some pulsars. Imagine a celestial magnifying glass the size of a solar system, bending and aligning photons into a unified stream. One theory suggests the nebula's core might house a hidden neutron star, its magnetic field acting like a cosmic collimator, funneling radiation through tunnels of ionized gas. Yet there's an even more intriguing possibility: guided signals. The nebula's beams aren't static, they pulse at irregular intervals, their frequencies clustering in bands that resemble harmonic resonance patterns. Some astronomers speculate these pulses could be the result of naturally occurring Whistler waves, where plasma instabilities create feedback loops that modulate the light. Others, however, note the eerie resemblance to theoretical models of directed energy communication, the kind an advanced civilization might use to transmit information across interstellar space. It's a long shot, but the nebula's structure, its nozzle-like gas conduits and reflective dust lanes, bear a curious similarity to proposed designs for photonic propulsion systems, where focused light could power spacecraft. Then there's the timing anomaly. Every 26 days, the primary beam dims briefly, as if eclipsed by an unseen object. No orbiting companion has been detected, leading to spine-tingling speculation. Could the Lighthouse Nebula be more than a natural wonder? Is something, or someone occasionally blocking its light intentionally? The truth remains obscured behind veils of gas and speculation. Whether it's nature's most dazzling optical fluke or something far more profound, the Lighthouse Nebula challenges us to rethink light's potential. Every beam is a riddle, every pulse a silent conversation we're only beginning to decode. And as long as those luminous fingers stretch into the dark, they'll keep drawing our gaze and our imagination toward the unknown. The frozen fire blazes in the depths of the Small Magellanic Cloud like a cosmic paradox. A region where flames dance inside perfect, glacier-like formations, their heat trapped inside cages of ice. At first glance, it resembles a celestial snow globe filled with flickering embers, a place where opposites don't just coexist but entwine in impossible harmony. Most cosmic phenomena obey the laws of thermodynamics. Fire melts ice, ice extinguishes fire. But here, the rules twist into something unrecognizable. The secret lies in the physics of extreme pressure and exotic states of matter. The frozen fire exists within a dense molecular cloud where temperatures hover near absolute zero, just a fraction above the coldest possible threshold in the universe. At these frigid extremes, gases that would normally ignite instead freeze into solid matrices, their molecules locking into crystalline lattices. But deep within these structures, pockets of ionized plasma churn, energized by residual starlight or cosmic rays. These aren't flames in the earthly sense. They're self-sustaining pockets of excited particles, their energy unable to disperse because the surrounding ice is too dense to let heat escape. It's like lighting a match inside a diamond. The spark has nowhere to go, so it burns in place, frozen in time. What keeps this delicate balance from collapsing? The answer might be magnetism. Spectrographic readings reveal intense magnetic fields threading through the region. Their lines of force so tightly wound they act like cosmic prison bars. These fields could be compressing the plasma, preventing it from overheating the surrounding ice while also shielding it from external disturbances. Imagine a candle flame encased in a magnetic force field, its heat contained so perfectly that the wax never melts. Yet the most baffling feature isn't the fire itself, it's the shapes it takes. The ice structures aren't random. They form intricate branching patterns resembling fractal trees or coral reefs, each branch lit from within by glowing veins of plasma. Some researchers compare it to a Lichtenberg figure, those eerie, lightning-burned scars etched into wood or glass but scaled up to cosmic proportions. How such precise geometries emerge in chaos is a mystery. One theory suggests acoustic vibrations from nearby pulsars might be sculpting the ice, sending shockwaves that carve it into these delicate forms while leaving the trapped fire untouched. Then there's the longevity. Normally, even the most stable plasmas would fizzle out within years, their energy bleeding into space. But the frozen fire has persisted for centuries, its flames neither growing nor fading, as if locked in a perpetual state of quantum stasis. Could this be a glimpse of a previously unknown phase of matter, something between plasma and Bose-Einstein condensate where energy and structure achieve perfect equilibrium? Whether it's a freak of physics or a cosmic art piece, the frozen fire defies every expectation. It's a place where the universe whispers secrets about the boundaries between states, about how delicate the balance between creation and destruction truly is. And as long as those flames keep burning inside their icy prisons, they'll challenge us to rethink what's possible even in the coldest corners of existence. The drifting gates hang in the void like cosmic keyholes, two massive ringed structures separated by light years, yet bound by an impossible synchronicity. Each resembles a giant hoop of shimmering metallic alloy, their surfaces smooth and unblemished despite floating in the dust-churned expanse of the Small Magellanic Cloud. At first glance, they might be mistaken for bizarre debris left by some ancient cataclysm, except for one chilling detail. Every 43 years, without fail, their orientations shift simultaneously, their rings tilting to match one another's angle with precision no natural object should achieve. It's as if invisible hands are adjusting them, aligning these gates for a purpose beyond our understanding. What could explain this eerie coordination? Wormhole theories abound. In science fiction, stable wormholes often appear as ringed portals, their mouths held open by exotic matter or negative energy. While no proven natural wormholes exist, the gate's periodic alignment mirrors hypothetical models of traversable tunnels in spacetime. Some astronomers speculate these structures could be dormant termini, an interstellar transit system frozen mid-activation, waiting for some trigger to reconnect them across the vast interstellar distance. The math almost works. If their interiors contain a singularity or dense energy field, the alignment might briefly stabilize a bridge between them, like turning a key in a locked door. Yet skeptics counter with natural explanations. The rings might be light-year-wide remnants of a peculiar supernova, their metallic hoops forged in a star's death throes and sent spinning in tandem by the explosion's shockwave. Their synchronized movements could then be a fluke of conservation of angular momentum, like two coins spun from the same flick of a thumb. But this doesn't account for their composition, a hyper-dense alloy that absorbs rather than reflects most radiation, making it nearly invisible except for faint thermal whispers along its edges. Natural metals don't behave this way. Then there's the folklore. Among astronomers who study the gates, whispers persist of odd radio pulses detected during alignments, brief, broadband bursts resembling the handshake signals of man-made communication relays. No published studies confirm this, but the stories fuel speculation. Could these be artifacts of a lost civilization's infrastructure, left behind when their builders vanished? Or perhaps a natural phenomenon we've yet to categorize, like lightning in a planet's atmosphere before we understood electricity? The most unsettling possibility isn't that the gates are artificial, it's that they're alive. Some theorists propose they might be a form of macro-scale quantum entanglement, where the rings behave as a single object despite their separation, their particles instantaneously influencing each other across space. If true, their alignments wouldn't be mechanical adjustments, but something far stranger, a cosmic organism twitching in its sleep. Whether dormant technology, freak physics, or something beyond our current science, the drifting gates loom as a riddle wrapped in celestial silence. Their next alignment is already on the calendar, a date circled by telescopes worldwide. Will they open, signal, or simply tilt again, mocking our attempts to decipher their purpose? Until then, they float patient, enigmatic, and utterly indifferent to the weight of our curiosity. The Siren Star pulses in the heart of the Small Magellanic Cloud like a cosmic metronome, its ultraviolet flares cresting and fading in a rhythm that feels unsettlingly familiar. Unlike the chaotic flicker of most variable stars, its bursts follow a precise 23.6-hour cycle, a cadence that mirrors Earth's circadian rhythm so closely, it raises an eerie question. Is this a cosmic coincidence or something far more intentional? At first glance, the star appears ordinary, a mid-sized blue giant burning hotter than our sun, its surface churning with magnetic storms, but its emissions tell a different story. Every pulse of UV light arrives like clockwork, intensifying and dimming in waves that could almost be mistaken for a heartbeat. Even stranger, those pulses cluster into longer 90-minute cycles matching the human ultradian rhythm, the natural ebb and flow of alertness and rest our bodies experience throughout the day. It's as if the star is echoing the very patterns encoded in our biology. Astronomers first dismissed the synchronicity as a fluke. After all, the universe runs on infinite permutations. Eventually, something would align with human rhythms by sheer chance. But statistical models tell a different tale. The odds of a natural star mimicking our internal clocks this precisely are astronomically slim, somewhere in the realm of 1 in tens of billions. That's not just unlikely, it's statistically deafening. So what could explain it? One theory leans into the uncanny. Certain frequencies of ultraviolet light are known to influence biological processes on Earth, from plant photosynthesis to animal melatonin production. Could the Siren Star be a natural but exceptionally tuned emitter, its radiation sculpted by some cosmic quirk into these strangely resonant waves? Imagine a stellar nursery with just the right density of surrounding dust, bending and filtering the star's light into these rhythmic bursts as it passes through. Then there's the more provocative explanation, artificial tuning. Some researchers point to the star's unusual metallicity. Its atmosphere is laced with elements like europium and holmium, rare earth metals prized in human technology for their conductive properties. While these occur naturally, their concentration here is oddly high, leading to whispers of stellar engineering. The idea that an advanced civilization might modify a star's output for communication or energy harvesting. If so, the rhythmic pulses could be a side effect, like the hum of a distant power grid resonating at a frequency we're biologically primed to notice. But the most spine-tingling possibility isn't that the star was designed for us. It's that its rhythm is universal. Circadian rhythms exist across terrestrial life, from fruit flies to fungi, suggesting they're deeply rooted in the physics of our world. If these patterns emerge from fundamental constraints like planetary rotation or the thermodynamics of carbon-based chemistry, then perhaps the Siren Star isn't echoing us. Perhaps we're both echoing something older, a deeper cosmic tempo written into the fabric of life itself. For now, the Siren Star keeps its secrets, pulsing across the light years with hypnotic regularity. Every UV flare is a question wrapped in light, a coincidence, a message, or a mirror. Until we learn to listen more closely, its song will remain just out of reach, a lullaby sung in a frequency we instinctively recognize but can't yet understand. The ink spot floats in the Small Magellanic Cloud like a hole punched through reality, a sphere of perfect blackness that devours every wavelength thrown at it. Unlike the chaotic fury of a black hole or the sooty darkness of cosmic dust, this anomaly absorbs with eerie silence, reflecting nothing, emitting nothing, as if light itself vanishes the moment it touches the surface. Even the blackest human-made materials like Vantablack still scatter traces of infrared or microwaves, but the ink spot, it's a cosmic void in miniature, a place where the universe's usual rules of radiation and reflection simply stop applying. At first glance, you might mistake it for a rogue black hole, an object so dense its gravity traps even light. But there's no accretion disk swirling around it, no telltale X-rays screaming from tortured matter spiraling inward. Probe it with radio telescopes and the silence is absolute. Unlike a black hole which betrays its presence through gravitational interactions with nearby stars, the ink spot drifts undisturbed, indifferent to the celestial ballet around it. It's not warping space-time, it's just there, a shadow where no shadow should logically exist. So what could create such an unnatural darkness? The leading theory points to an exotic state of matter, a tightly packed lattice of quantum dots or metamaterials structured to cancel out all incoming energy. Picture a sponge, but one designed at the atomic level to soak up photons rather than water. In labs, scientists have engineered similar materials using microscopic pillars or cavities to trap light, but never on this scale. If the ink spot formed naturally, it would require conditions so precise they border on impossible. A dying star's core cooling into a crystalline matrix with perfect light-absorbing geometry, or perhaps a cloud of ultra-dense particles aligning by chance into the universe's most efficient light trap. Then there's the temperature paradox. All objects emit thermal radiation based on their heat. Even the coldest ice in space glows faintly in microwaves. Yet the ink spot registers at absolute zero, as if it's siphoned away not just light, but the very concept of temperature. Some models suggest it might be a cosmic heat sink, funneling absorbed energy into higher dimensions or quantum states we can't detect. Others propose it's a frozen artifact of the early universe, a bubble of vacuum decay where the laws of thermodynamics briefly flickered out of existence. The most unsettling possibility, it's not a natural object at all. The ink spot's perfection echoes theoretical designs for stealth spacecraft. Imagine a vessel cloaked not just in invisibility, but in absolute erasure, rendering itself undetectable by swallowing every probing signal. Given its location in the Small Magellanic Cloud, a satellite galaxy teeming with unexplained phenomena, the notion isn't entirely far-fetched. Yet for all our speculation, the ink spot remains silent, a cryptic blot on the cosmos. Whether it's a freak of physics, a relic of alien engineering, or something beyond our current imagination, one thing's clear: this isn't just darkness. It's a riddle written in negative space, a reminder that even in the brightest corners of the universe, there are still places where light simply vanishes. The cosmic honeycomb stretches across the Small Magellanic Cloud like a celestial blueprint, a sprawling grid of star clusters arranged in near-perfect hexagonal cells, each node a glittering stellar metropolis separated by vast, empty corridors. It's as if some cosmic architect sketched a galactic beehive into the void, then populated its chambers with newborn suns. Most star-forming regions are chaotic, their structures sculpted by the messy interplay of gravity and turbulence. But here, order reigns supreme, with clusters spaced so uniformly you could plot their positions with a protractor. What forces could craft such precision? One explanation lies in the physics of shock waves. When a supernova detonates, it sends ripples through surrounding gas clouds, compressing the material into dense sheets. If multiple explosions occur in sequence, their shock fronts can intersect, creating a lattice of high-pressure zones where stars ignite like matches struck along folded paper. Over time, these zones might stabilize into the honeycomb's eerie symmetry, each cell a fossilized echo of long-dead stars' final breaths. Simulations show similar patterns emerging in lab experiments with vibrating fluids, nature's way of finding order amid chaos. Yet there's a wrinkle in that theory. The honeycomb cells aren't just geometrically aligned, their stellar populations are uncannily synchronized. Clusters on opposite sides of the grid contain stars of identical age and composition, as if birthed in the same cosmic instant. Supernova shocks don't account for that level of coordination unless the explosions themselves were timed a scenario so statistically improbable, it borders on absurd. This has led some researchers down a darker path: intentional design. Could the honeycomb be a megastructure, a deliberate arrangement of stars engineered for some unfathomable purpose? The idea isn't pure fantasy. On Earth, humans have long used grids for efficiency, from agricultural plots to city blocks. An advanced civilization might scale this logic to cosmic proportions, sculpting star clusters into a lattice to harness energy, facilitate travel, or even transmit information. The hexagonal pattern is particularly compelling. It's nature's most efficient tiling system, minimizing wasted space, a sensible choice for any builder, organic or otherwise. Then there's the silence. If the honeycomb were artificial, you'd expect traces of activity, heat signatures, engineered emissions, even debris. But scans reveal only ordinary starlight, leaving theorists divided. Is this a natural marvel we've yet to fully understand, or a relic so ancient its builder's fingerprints have faded into the background hum of the universe? One clue might lie in the voids between cells. These corridors aren't entirely empty. They hum with faint magnetic fields, threads of force weaving through the grid like invisible wires. Some models suggest these fields could be remnants of a scaffolding system, cosmic construction rods, used to position the clusters before dissolving into the void. Others argue they're simply the scars of gas filaments stretched thin by eons of expansion. The cosmic honeycomb doesn't just challenge our understanding of star formation, it blurs the line between accident and intention. Every symmetrical cell is a riddle, every empty corridor a silent witness to forces we're only beginning to glimpse. Whether it's nature's masterpiece or something far more profound, one thing's certain: this isn't just a cluster of stars. It's a question etched in fire, waiting for us to unravel its geometric poetry. The exoplanet drifts silently in the Small Magellanic Cloud, a world with a haunting talent. It whispers back fragments of Earth's past like a cosmic parrot. Imagine tuning a radio and suddenly hearing a garbled broadcast from 60 years ago, a snippet of a moon landing or a crackling Cold War transmission echoing across the void. That's exactly what astronomers encountered when they first detected this enigmatic planet's signals. It doesn't generate its own broadcasts, it replays ours, stitching together distorted clips of humanity's radio history into a disjointed, looping montage. How is this possible? The leading theory hinges on an extraordinary natural phenomenon. The planet might be cloaked in a dense, ionized atmosphere layered with metallic particles, a celestial tape recorder of sorts. As Earth's radio waves travel through space at the speed of light, some could have been captured and slowed by this atmospheric filter, bouncing between its charged layers for decades before finally escaping back into space, their signals stretched and warped by the journey. Picture shouting into a canyon and hearing your voice rebound moments later, except this canyon is light years wide, and the echoes carry decades of history. Yet the specifics defy easy explanation. The exoplanet doesn't just delay signals, it curates them. Certain broadcasts repeat more frequently old emergency alerts, fragments of Morse code, even bursts of static that align with no known transmissions. Some researchers suggest its atmosphere might act like a natural quantum hard drive, with charged particles arranging themselves into stable patterns that store snippets of passing radio noise. Others propose something eerily deliberate, that the planet's magnetic field resonates selectively with certain frequencies, amplifying them like a cosmic radio dial stuck between stations. Then there's the mimicry angle. Over the past 5 years, the exoplanet has begun rebroadcasting signals with slight, unsettling variations. A news report from 1969 with altered phrasing, a Soviet-era number station transmission counting backward instead of forward. These anomalies have sparked speculation that we're not just hearing echoes but interpretations. Could the planet's atmosphere be distorting the signals in a way that resembles learning? It's a stretch, but not impossible. Complex plasma interactions can theoretically produce feedback loops that remix incoming data, like a celestial echo chamber with a mind of its own. The most spine-tingling possibility: we're not the first to notice this phenomenon. The planet's replaying signals include unidentifiable bursts, high-frequency pulses that match no known human technology. Could these be fragments of another civilization's broadcasts, snagged by the exoplanet's atmosphere long before we began listening? If so, this world might be more than a curiosity. It could be a silent archaeologist preserving whispers from civilizations lost to time. For now, the exoplanet keeps its secrets, looping our past back to us in fragments. Every signal is a puzzle piece, a reminder that even in the silent depths of space, the universe finds ways to talk back. Whether it's a fluke of physics or something far stranger, one thing's certain: when we listen closely, we might not just hear echoes, we might hear the universe listening too. The Titan's halo looms in the darkness of the Small Magellanic Cloud like a cosmic crown, a rogue planet, untethered from any star, yet encircled by a ring system so vast it defies every law of orbital mechanics. Most ringed worlds, like Saturn, owe their dazzling halos to the gentle tug of their host star's gravity, which keeps debris neatly arranged in flat, stable disks. But this nomadic giant drifts alone through the void, its rings stretching twice the distance from Earth to the Moon, each segment locked in perfect equilibrium without the gravitational anchor of a sun. It's as if someone took a celestial bullseye and hurled it into deep space, expecting it to remain flawlessly intact, and against all odds it did. What sorcery keeps these rings from flying apart? Start with the planet itself, a behemoth 12 times Jupiter's mass, its gravity fierce enough to sculpt nearby space into a labyrinth of stable zones. Ordinarily, rings this far from a star would disperse or clump into moons within millennia, but the Titan's halo thrives, its icy and metallic debris orbiting in razor-sharp bands, each particle moving with clockwork precision. The secret might lie in an invisible dance between forces. The planet's rotation generates a magnetic field so intense, it acts like a cosmic loom, weaving charged ring particles into alignment. Meanwhile, microscopic moons, no larger than city blocks, could be shepherding the gaps between rings, their tiny but persistent gravity nudging stray debris back into place like celestial sheepdogs. Yet the real enigma isn't just stability, it's origin. Where did these rings come from? A rogue planet shouldn't have the raw material for such extravagance. One theory suggests a cataclysmic collision in its past, a moon shattered by impact, its remains captured and flattened into this dazzling disk. But simulations struggle to explain the ring's sheer scale. The debris field would need to be impossibly dense to account for its current breadth. Another possibility: the planet might be an interstellar refugee, its rings the remnants of a close encounter with a neutron star or black hole, their tidal forces stripping away its outer layers and sculpting them into this improbable jewelry. Then there's the wildest idea of all, that the Titan's halo isn't natural. Ring systems are rarely this symmetrical or enduring without constant replenishment. Some researchers whisper about megastructures, artificial stabilizers hidden within the rings, their presence betrayed only by faint infrared glows near the gaps. Could these be the ruins of an ancient orbital engineering project, a failed Dyson swarm, or a long-abandoned cosmic supercollider, or perhaps something even more profound, a signal deliberately crafted to outlast its creators, its perfection a beacon in the dark? Every scan deepens the mystery. The rings don't just reflect light, they polarize it, twisting passing starlight into spirals that suggest intricate magnetic interactions. Some sections glow faintly in radio waves, as if charged by an unseen energy source. And then there's the oddest detail: the rings are migrating. Over the past decade, their inner edges have crept infinitesimally closer to the planet, as though drawn by some slow, invisible tide. Whether it's a masterpiece of natural physics or something beyond our current understanding, the Titan's halo stands as a testament to the universe's capacity for wonder. It's a riddle wrapped in ice and dust, a cosmic contradiction that refuses to fade into the dark. And as long as those rings keep spinning, they'll remind us that even in the loneliest corners of space, the universe still finds ways to astonish. The neon vein cuts through the Small Magellanic Cloud like a celestial scar, a luminous river of electric blue plasma, pulsing with enough energy to outshine entire star clusters. Stretching nearly 20 light-years from end to end, this glowing filament doesn't just drift aimlessly. It follows an unnaturally straight path, as if guided by invisible rails. Most cosmic structures bend and twist under the chaotic pull of gravity, but the vein defies the disorder, its edges sharp, its course unwavering. Peer through a telescope, and you'll swear it's a highway painted in neon, a radiant thoroughfare through the void. What could possibly keep such a volatile structure intact? The answer crackles in the silence between stars: magnetism. The vein isn't just plasma, it's a cosmic current, channeled and contained by magnetic fields so powerful they'd snap a spaceship in half like a twig. Imagine an underground subway system, but instead of tunnels, the tracks are forged from lines of force woven through space itself. These magnetic highways don't just guide the vein, they compress it, squeezing the superheated gas into a cohesive stream that glows with synchrotron radiation, the same eerie light emitted by particle accelerators on Earth. Yet the vein's true mystery lies in its origins. Plasma this concentrated usually erupts from violent events: supernova, quasar jets, or the collisions of neutron stars. But scans reveal no wreckage at either end of the filament, no stellar corpse or black hole to explain its existence. Instead, the vein appears to emerge from empty space, as if tapped into some unseen reservoir of energy. Some astronomers speculate it could be a cosmic ley line, a remnant of the early universe when magnetic fields were strong enough to sculpt the cosmos on galactic scales. Others propose a more unsettling idea, that the vein is a discharge from something larger, a hidden structure or dimensional boundary bleeding energy into our reality like a live wire dangling in water. Then there's the lifeblood of the vein, its movement. Unlike static nebulas, this plasma river churns with purpose, its currents flowing at nearly 1,000 kilometers per second. Spectral analysis reveals heavy elements: oxygen, nitrogen, even traces of gold lacing its glow, suggesting it's not just transporting energy but matter. Could this be a delivery system for the building blocks of planets, ferrying metals forged in distant stellar furnaces to new corners of the galaxy? The implications are staggering. If magnetic highways like this exist elsewhere, they might be the universe's silent couriers, redistricting the ingredients for life itself. The most mesmerizing detail, though, is the vein's rhythm. Every 11 hours, its brightness spikes by precisely 8%, a pulse so regular it mimics the beating of a heart. No known natural process explains this cadence. Some researchers whisper about magnetars, highly magnetic neutron stars, whose invisible tremors could be resonating along the filament like plucked guitar strings. But there's no detectable source, no cosmic musician plucking at the veins' edges. It's as if the structure has its own hidden metronome ticking away in the dark. Whether it's a fossil of the universe's infancy or the symptom of something far stranger, the neon vein refuses to be ignored. It's a reminder that even in the vast emptiness of space, there are currents, roads paved with fire and magnetism, humming with secrets we're only beginning to trace. And as long as it glows, it will beckon us to follow its light, wondering where it leads and what might be traveling along it. The Mirage Quasar flickers through the Small Magellanic Cloud like a cosmic illusionist, one moment blazing brightly at a precise coordinate, the next appearing light years away without physically moving at all. Unlike typical quasars whose brilliant jets anchor them firmly in place, this enigma seems to dance across the void, its position shifting in telescope data as if reality itself can't decide where it belongs. The first astronomers to observe it dismissed the discrepancies as calibration errors, but repeated measurements confirmed the impossible. The quasar's light arrives from multiple directions, bending the rules of cosmic navigation. So how does a celestial object defy the most basic law of physics that something can't be in two places at once? The answer lies in the warped fabric of space-time. The Mirage Quasar sits behind a dense, invisible barrier, likely a cluster of dark matter or a rogue black hole, whose gravity acts like a funhouse mirror, twisting the quasar's light into multiple paths. Imagine holding a broken mirror shard up to a candle. Suddenly, you'd see dozens of scattered flames, each a distorted reflection of the original. Similarly, the quasar's radiation bends around the cosmic obstacle, reaching us along different routes, each path creating the illusion of a separate object. But here's where it gets stranger. These ghost quasars aren't just static mirages, they flicker out of sync. Light taking a longer path arrives later, meaning some images show the quasar as it appeared centuries before others. It's like watching a star's past and present simultaneously, a celestial time machine powered by gravitational sleight of hand. Even more unsettling, one of the mirage images occasionally brightens unpredictably, as if something vast and unseen is drifting between us and the quasar, magnifying its light like a lens. Could this be evidence of dark matter clumps or primordial black holes, the universe's hidden architects warping the view? The Mirage Quasar challenges more than just observation. It probes the limits of our cosmic maps. If gravity's tricks can displace objects this dramatically, how many other phantoms lurk in our star charts? Every flicker of this quasar is a reminder that the universe isn't just stranger than we imagine. It's stranger than we can imagine, bending light, time, and perception into puzzles we're only beginning to solve. The clockwork galaxy spins through the Small Magellanic Cloud like a celestial timepiece, its spiral arms not just drifting, but turning with the precision of interlocking gears. Every star, every dust lane moves in perfect synchrony, their orbits calibrated so flawlessly that the entire structure resembles a vast cosmic mechanism, each part meshing effortlessly with the next. Most galaxies churn with chaotic motion, their stars swaying to the messy rhythms of gravity. But here, order reigns supreme, as if some unseen hand wound up the galaxy and set it ticking eons ago. What could explain such unnatural harmony? Start with the stars themselves. Normally, stellar orbits vary wildly. Some loop close to the galactic core, others stray to the fringes in elongated paths. But in the clockwork galaxy, stars of similar mass trace nearly identical orbits, their speeds so finely tuned that they form concentric layers of motion, like the wheels inside a pocket watch. Even more bizarre, these layers shift in unison when one group of stars accelerates. The others adjust their pace to match, maintaining the galaxy's eerie symmetry. It's as if they're connected by invisible strings, dancing to some cosmic conductor's tempo. This synchronization defies conventional astrophysics. Gravity alone can't account for such precision. The forces required to keep billions of stars aligned would tear most galaxies apart. One theory points to dark matter, suggesting an extraordinarily dense, perfectly balanced halo might be orchestrating the motion from behind the scenes. Picture an immense, invisible spindle running through the galaxy's core, its gravitational pull acting like an axle around which the visible stars rotate. Yet even this falls short of explaining the rhythmic adjustments, the way the galaxy's gears seem to anticipate shifts before they occur. Then there's the engineered angle. The clockwork galaxy's arms aren't just orderly, they're mathematically optimal. Their spiral follows the golden ratio, a pattern found in everything from Nautilus shells to hurricanes, but never before observed on such a colossal scale. Some researchers argue this could hint at intentional design, a megastructure forged by intelligence beyond our comprehension. Imagine a civilization so advanced they could rearrange stars into a galaxy-sized engine, harnessing their motion to power some unfathomable technology. The idea isn't as far-fetched as it sounds. Human engineers already use orbital mechanics to slingshot probes across the solar system. Scaling that principle up to galactic proportions would merely require mastery over stellar physics we've barely begun to grasp. Yet the most haunting detail isn't the galaxy's motion, it's the silence. If this were a machine, where's the energy output, the waste heat, the emissions? Scans reveal no abnormal radiation, no telltale signatures of artificial activity. Just cold, flawless motion, ticking away in the dark as it has for billions of years. Whether it's nature's most intricate fluke or something far more profound, the clockwork galaxy challenges everything we thought we knew about cosmic chaos and order. Every synchronized star is a cipher, every rotation a silent testament to mysteries we're only beginning to unravel. And as long as those galactic gears keep turning, they'll remind us that even in the vastness of space, perfection might not always be an accident. The silent nova detonated in the Small Magellanic Cloud with all the spectacle of a fireworks show, except no one heard it. Most supernovae announce their deaths with thunderous shockwaves, rippling through interstellar gas like cosmic tsunamis. But this one shattered the mold, its explosion unfolding in eerie quiet, leaving astronomers scrambling to explain how a star could die without screaming into the void. At first, researchers assumed their instruments had failed. Supernovae are supposed to be messy, violent affairs, their shockwaves compressing nearby gas clouds into glowing ripples that linger for centuries. Yet when telescopes turned toward this event, they found no such echoes. The surrounding nebula remained undisturbed, its dust lanes smooth and unruffled, as if the star had simply vanished. Only the blistering ultraviolet afterglow betrayed the truth. A massive stellar core had collapsed, unleashing enough energy to outshine galaxies, but channeling it all inward like a bomb wrapped in a soundproof blanket. The key to this silence lies in the star's final moments. Normally, a dying giant star's outer layers rebound off its collapsing core, creating a shockwave that rips through space at hypersonic speeds. But the silent nova's progenitor might have been wrapped in an extraordinary cocoon, a dense shell of previously ejected material acting like a cosmic muffler. Picture a diver slipping into water without a splash. The star's explosion plunged into its own surrounding gas, the energy absorbed before it could ripple outward. Spectrographic analysis supports this. Traces of nickel and iron detected in the aftermath suggest the shockwave stalled, its energy dissipating as heat rather than sound. Then there's the magnetic twist. Some models suggest the star's magnetic field might have been unusually tangled, funneling the explosion's energy into narrow jets instead of a spherical blast. Like squeezing a balloon until it bursts in one direction, this focused detonation would have minimized broader shock effects. Supporting this, X-ray observations revealed faint twin beams lancing from the remnant telltale signs of a failed supernova that couldn't quite punch through its own stellar shroud. The implications are staggering. If stars can die quietly, we might be missing entire populations of supernova, their light dimmed and their shockwaves muted. Telescopes could be overlooking cosmic fireworks happening right in our galactic backyard, simply because they don't fit the traditional template of stellar death. Worse, these silent explosions might leave behind different remnants, not the vibrant nebulae we know, but dark, collapsed objects lurking unseen. The silent nova doesn't just challenge our understanding of stellar deaths, it rewrites the rules. Every observation peels back another layer, revealing how much we still don't know about the universe's most violent and sometimes most silent moments. The gravity fountain defies the most fundamental law of the cosmos, the pull of gravity itself, in a spectacle so baffling it turns physics textbooks into works of fiction. Picture a region in the Small Magellanic Cloud where shattered asteroids, clouds of ionized gas, even wayward comets don't drift downward toward some massive attractor, but instead float steadily upward, as if space itself has tipped sideways, and down is now a direction no one told these objects about. Telescopes trained on this anomaly capture debris suspended in mid-flight, some pieces accelerating against the gravitational grain like leaves caught in a cosmic updraft. What could warp gravity's grip so dramatically? One explanation dives into the realm of hypothetical antigravity, a repulsive force theorized in quantum physics but never observed in nature. If exotic matter with negative mass exists here, it might generate a push strong enough to counteract planetary or stellar attraction, effectively creating a fountain where gravity flows backward. Imagine a hidden geyser of space-time, spewing invisible repulsion instead of water, its force bending the rules of motion. Yet there's a twist that challenges even this radical idea. The fountain's effects aren't constant. Objects within its influence don't just hover, they oscillate, bobbing like buoys in an invisible tide. Some accelerate upward for days before abruptly reversing course, as if caught in a tug of war between competing forces. This volatility points to something stranger than a simple antigravity field. Could the fountain be a knot in spacetime itself? Einstein's equations allow for regions where gravity's fabric frays, creating topological defects. Think of a crumpled tablecloth with spots where marbles roll uphill instead of down. If such a defect exists here, it might explain why the fountain's influence flickers. The seam in spacetime could be unstable, its repulsive effects waxing and waning as cosmic energies shift around it. Then there's the matter of location. The fountain sits at the convergence of three faint but powerful magnetic fields, their lines of force intersecting in a way that warps nearby plasma into helical patterns. Some researchers propose these fields might be twisting spacetime itself, generating a localized gravity well that inverts the usual rules. Picture a whirlpool where water spirals outward instead of in, a fluid dynamics paradox scaled up to celestial proportions. If magnetism can distort gravity's behavior here, it would rewrite our understanding of how fundamental forces interact in extreme environments. The most tantalizing clue, though, lies in the fountain's silent partner, a nearby pulsar spinning at nearly 1,000 times per second, its rhythmic pulses synced with the fountain's fluctuations. Every time the pulsar's beam sweeps across the anomaly, sensors detect a faint tremor in the upward flowing debris, as if the star's emissions are fueling the phenomenon. Could this be evidence of a naturally occurring gravity shield, a region where the pulsar's intense radiation pressure counters gravity's pull? Or might the pulsar be entangled with the fountain through higher dimensional physics, its rotations twisting spacetime into this bizarre configuration? Whatever the truth, the gravity fountain stands as a monument to the universe's capacity for rebellion. It's a place where the cosmos tosses out the rules, where down becomes optional, and where every drifting fragment is a challenge to our understanding of reality itself. Until we unravel its secrets, it will keep defying gravity and logic, one floating asteroid at a time. The celestial mural hangs in the depths of the Small Magellanic Cloud like a starry cipher, a sprawling arrangement of young, luminous stars that seem to trace the outlines of symbols eerily reminiscent of ancient earthly petroglyphs. At first glance, it's easy to dismiss the resemblance as pareidolia, the human brain's tendency to find familiar shapes in randomness, like seeing faces in clouds. But the longer you study this stellar canvas, the harder it becomes to ignore. There, etched in blue-white giants and crimson supergiants, are undulating lines that mirror Neolithic spirals, angular formations echoing Sumerian cuneiform, even a near-perfect rendition of the Egyptian Ankh, its loop and cross formed by intersecting stellar streams. The odds of such precise alignments occurring naturally are so infinitesimal, they border on absurd. What could explain this cosmic inkblot test? One possibility lies in the murky interplay of gravity and chance. Stars don't form in isolation, they emerge from collapsing gas clouds, their positions dictated by turbulence and magnetic fields. Under extremely rare conditions, these forces might sculpt stellar nurseries into temporary shapes that echo human iconography, like waves briefly freezing into the outline of a ship. The mural stars are all relatively young, suggesting they haven't yet drifted far from their birth sites, preserving their original configuration like a snapshot of a fleeting moment. Given enough time, these patterns will distort and fade, leaving no trace of their brief, uncanny order. Yet the mural's persistence nags at the edges of plausibility. Some of its symbols span dozens of light years, their outlines maintained by stars of vastly different masses and life expectancies. Gravity alone shouldn't keep such disparate objects in alignment unless something else is at work. One fringe theory points to dark matter's invisible hand, suggesting dense filaments of this mysterious substance might be shepherding the stars into these formations like a sculptor pressing thumbs into clay. Others propose a far older influence. Primordial magnetic fields, relics from the universe's infancy, could still thread through this region, their lines of force guiding stellar placement like iron filings on a sheet of paper. Then there's the unsettling alternative, intentionality. Could the mural be a deliberate arrangement, a message scrawled across light years by intelligence beyond our own? The idea isn't as outlandish as it sounds. Humanity has long used the stars as a canvas for meaning, from constellations mythologized by ancient cultures to the Arecibo message, our own crude attempt at cosmic graffiti. An advanced civilization might leverage stellar engineering to create durable symbols, positioning young stars into legible patterns that outlast civilizations. The mural's symbols aren't random doodles. They cluster in recurring motifs found across Earth's earliest writing systems, as if distilling universal concepts like life, cycle, or warning. Or perhaps the truth lies somewhere between accident and design. The universe operates on repeating mathematical principles. The same spirals in seashells govern galaxy arms. The same ratios in flower petals appear in planetary orbits. If these archetypes are woven into reality's fabric, might they emerge even in star formation, a kind of cosmic convergent evolution? The celestial mural could be a Rosetta Stone not for aliens but for physics itself, a place where the universe's hidden patterns briefly rise to the surface, whispering in a language we're only beginning to decode. For now, the mural remains suspended between coincidence and intention, its symbols glowing defiantly against the dark. Whether it's a fluke of stellar mechanics, a monument to lost minds, or something beyond both, one thing's certain: it challenges us to reconsider how much meaning we project onto the cosmos and how much might already be written in the stars. The phantom jet streaks through the Small Magellanic Cloud like a ghostly bullet, an invisible force carving through cosmic gas clouds without leaving a visible trail. Telescopes can't directly image it, sensors can't pinpoint its source, yet its presence screams across the void through sheer destruction. Picture a sniper's shot seen only by the splintering of its target here. Vast molecular clouds split cleanly down the middle, their edges glowing where something unimaginably powerful has torn through at relativistic speeds. The evidence is etched in the wreckage, ionized gas filaments vibrating with residual energy, dust plumes recoiling in perfect parallel lines, as if the universe itself flinched from an unseen strike. What could slice through interstellar space with such invisible precision? One spine-chilling theory points to dark matter, not as passive halos but as an engineered propulsion medium. Imagine a thread of exotic matter, denser than neutron star material, funneled into a beam so fine it interacts only gravitationally with normal matter. As it moves, it warps space-time around it like a cosmic plow, shearing everything in its path without radiating heat or light. If such technology exists, it would explain the jet's phantom nature, a weapon or a propulsion system built by civilizations wielding dark matter as a tool rather than a mystery. Yet there's a wilder possibility: stealth. Human militaries already craft aircraft to evade radar. Might an advanced species engineer stellar-scale cloaking? The jet's trajectory reveals eerie refinement. It skirts star clusters and nebulas with uncanny precision, as if navigating. Some researchers suggest its invisibility stems from metamaterials, substances engineered to bend light around the beam completely. Picture a river diverted around a boulder. Here, electromagnetic waves flow smoothly around the jet, rendering it undetectable except for the wake of its passage. The most unsettling detail isn't the jet's stealth, but its acceleration. Debris patterns suggest it doesn't decelerate or curve, it moves in flawless straight lines, defying gravity's pull. Natural phenomena don't behave this way. Comets swerve around stars, asteroids tumble in chaotic arcs. This thing moves with purpose, as if locked onto coordinates beyond our perception. Could it be a tracer round fired in some galactic conflict eons ago? A probe sent to scout distant systems, its creators long gone, or worse, something still operational, humming silently through the dark, its mission unknown. Until we glimpse the unseen hand behind it, the phantom jet will haunt the edges of our understanding, a reminder that the universe's greatest threats might not be the monsters we see, but the ones we can't. The Oracle Nebula drifts through the Small Magellanic Cloud like a cosmic fortune-teller, a luminous cloud of gas that shouldn't just reflect celestial events but seemingly anticipates them. Most nebulas brighten in response to nearby stellar activity, their gases ionized by the radiation of existing stars, but this one, it flickers to life hours, sometimes days before a supernova detonates nearby, as if privy to the universe's secrets before they unfold. Telescopes have recorded it pulsing like a warning beacon days prior to a massive star's collapse, its filaments lighting up in patterns that mirror the coming explosion's expected shockwave. It's as if space itself is whispering prophecies through this ethereal structure, leaving astronomers torn between awe and disbelief. What could explain such impossible foresight? One camp argues for hidden triggers, invisible forces weaving cause and effect behind the scenes. The nebula might be threaded with ultra-dense filaments of dark matter, gravitational ripples that transmit impending stellar collapses faster than light, like cosmic telegraph wires. Imagine tapping a spider's web and feeling vibrations before the prey strikes. The Oracle could be sensing disturbances in spacetime's fabric, its glow responding to tremors we can't yet detect. Supporting this, some models suggest quantum entanglement might play a role, particles in the nebula's core linked to those inside doomed stars, their states shifting in unison across light years, flashing a silent alarm before the main event. Yet there's a more unsettling interpretation: precognition, not in the mystical sense, but as a gap in our understanding of physics. Could the nebula be exploiting some unknown temporal mechanism where cause and effect aren't strictly linear? Certain solutions to Einstein's equations permit closed time-like curves, theoretical loops where information might travel backward in time without violating causality. If the Oracle's structure creates such a curve, perhaps through a freak alignment of magnetic fields and exotic matter, it might receive faint echoes of future events, imprinting them as premature glows. Picture a pond where ripples arrive before the stone drops. The nebula could be swimming in time's eddies, catching glimpses of what's to come. The skeptics, of course, have simpler explanations. The nebula's predictions might be self-fulfilling prophecies. Its sudden ionization could destabilize nearby stars, triggering the very collapses it appears to foresee. Or perhaps we're witnessing a cosmic version of confirmation bias, where random flickers are only remembered when they coincide with later events, while countless false alarms go ignored. Then there's the most tantalizing clue of all. The Oracle's accuracy is improving. Over the past decade, its forecasts have grown more precise, their lead times aligning ever closer with subsequent supernova. Coincidence, or is something or someone calibrating it? Whether it's nature's most elaborate fluke or a window into physics we've yet to imagine, the Oracle Nebula refuses to be ignored. Every glow is a riddle wrapped in stardust, challenging us to question not just how the universe works but when. From the Ghostly Nebula X-1's eerie, fuel-less glow to the gravity-defying antics of the Phantom Jet, these 50 cosmic oddities aren't just curiosities, they're revolution in motion. Every strange object in the Small Magellanic Cloud forces us to rewrite the rules, proving the universe is far wilder than our textbooks dared to imagine. Think about the hexagonal nebula's razor-sharp angles defying the chaos of space, or the Quantum Quasar shimmering in two places at once, mocking our grasp of reality. And who could forget the hollow asteroid, a planetary husk scooped clean with impossible precision? Each one is a crack in the foundation of known physics, whispering questions we're only beginning to ask. But here's the thrilling part. This isn't just a catalogue of weirdness. These anomalies are clues, pieces of a cosmic puzzle we're still assembling. The clockwork pulsar's flawless rhythm hints at undiscovered forces governing time. The fractal galaxy's infinite spirals suggest hidden patterns woven into the fabric of existence. Even the exoplanet, replaying Earth's radio history like a celestial phonograph, challenges what we thought possible about memory and matter. Every discovery peels back another layer, revealing how much we still don't know and how much wonder remains. So now it's your turn. Which of these cosmic rebels blew your mind? Was it the storm egg crackling with imprisoned lightning, the Mirror Galaxy Fragment reflecting worlds with unsettling clarity? Or maybe the binary void, those twin spheres of nothingness hanging in perfect sync? Drop your favorites in the comments. I'd love to hear which mysteries keep you up at night. And if you're hungry for more deep space enigmas, don't forget to subscribe. The universe is vast, strange, and far from done surprising us. Together, let's keep unraveling its secrets, one celestial